Welcome to the DAX 2025 edition with Pragmatic Works. I'm Mitchell Pearson, and today we're tackling a bold claim. DAX is easy. And personally, I believe that. I know that might sound a little bit controversial, but stick with me because by the end of this session, you won't just believe it, you'll be writing DAX with confidence. So let's jump right in and write some DAX together. As we're getting started here, I do want to mention that this session will be recorded and will be living on YouTube. So feel free to come back and watch this session again and again, and as many times as it takes for you to feel more comfortable working with DAX. I also want to let you know that if you look in the description of this video below, you can actually download the Power BI file that we're using and the code that's being used throughout this session. So feel free to try to follow along. Now, if you're watching this live, that could be a little bit frustrating for you, but if you're watching this after it's been recorded, you have the ability to speed it up and slow it down and go through the material as many times as you need so that you can feel comfortable with that material. With that out of the way, let's jump right in and talk about the agenda. So in this class today, in this session, we're going to talk about the fundamentals of DAX. We're going to talk about using DAX as calculated columns and also as calculated measures. And then we're going to jump right in and we're going to take a look at understanding filter context and time intelligence and how to use the most important function in DAX, which is the calculate statement. So whether you are a beginner and you're new with DAX, or maybe you've been working with it for a while and you've really been struggling to understand it, or maybe even a veteran with DAX, you're going to get something out of the session today as we work through the session. After we cover calculate, we are also going to spend a moment talking about how to deal with multiple fact tables. How do we write our DAX when we have multiple fact tables in our model? And then we're going to take a look at visual calculations and how we can supplement our DAX with that. And of course, we have to cover Copilot and how we can use Copilot to help with our DAX journey as well. So I hope you're excited about this session because that's exactly what we're going to be doing today, talking about DAX. So what is DAX? DAX is, and it stands for, the Data Analysis Expression Language. And we use DAX within Power BI, the tabular model, within the semantic model in Fabric. We use DAX to add deeper analysis, the ability to do deeper analysis of our data, right? So I might use the Data Analysis Expression Language to do time intelligence calculations so I can look at my data and get the year-over-year difference, or get a rolling 3-month difference, or get a percent of total calculation. And so what we get out of the box once you pull this stuff into Power BI is you can do some just automatic summarizations of your data. But as soon as you want to do anything more advanced analytically, then that's where we start to really leverage and dive into this DAX expression language. And so we use DAX, that is the expression language that we use to add analytical value to our model within Power BI. So why do we have DAX? Well, we have DAX because when Microsoft started building out the Vertipack engine, which is the engine in the background, they decided to go with a new programming language. And the language that we're using here is DAX. And if you've worked with other traditional programming languages like Python or MDX or SQL, then DAX is in and of itself, as I mentioned at the beginning, it's easy because there's less of a learning curve to getting started with DAX. And at the core, when you're building calculated columns, it has a lot of familiarity with like Excel functions, which a lot of users who are coming to Power BI, that are coming to Fabric, they already have some familiarity with that. So it makes that learning and that journey a little bit easier from the beginning. So that's why we have the DAX language. DAX is used primarily for really two things. And there's other things that DAX are used for, but two things that we're going to be covering in this session today. That is calculated columns and calculated measures. And really, honestly, the argument can be made that generally speaking, you really should never use DAX for calculated columns because there are some limitations and some drawbacks there. So if you're building a new column on a table, we really want to do that as close to the source as possible. So do it back in the Power Query editor as you're loading the data. If you're doing this in Fabric or using SQL, build your columns there and add that additional descriptive information, if you will, on those tables. But we can use DAX to build calculated columns. 95% or more of your time and your experience using DAX is actually going to be to build measures. And so let's talk about the difference between columns and measures. So when you're adding new columns to a table, maybe for descriptive purposes. So I am looking at my customer table and I want to be able to look at the age of a customer so that we can look at profit margins by age, or maybe an age breakdown. So what are our profit margins? What are our sales for all of the different age demographics? That is a column that we would add to our table because we're going to use that column to describe our data, to filter our data. So that's a very easy way to think of calculated columns. It's going to be descriptive attributes, descriptive columns that we add to a table. Another use case for calculated columns is trying to create a key column to facilitate a relationship within the model between two tables. We'll get to that later. We have an exact example that we're going to use to specify that. Now, as I mentioned from the beginning, when you're using DAX to write measures, that's really going to be about 95% of what you use DAX for. And so what do we get with measures? Well, the first thing we get is we get creating dynamic aggregations, right? So you build a measure, that measure gives you total sales. But as soon as you bring in one of those descriptive columns like year or age breakdown or customer or geography, country, automatically that calculation changes. It automatically is dynamic and it respects the filters that are being applied within the data model, right? And so those measures that we build are drastically different from columns because columns, when they are created at runtime, they are static and they do not change. But a measure is re-evaluated and recalculated every time we add a new filter. And so measures are very, very powerful within Power BI, and they give us that advanced analytical value that we talked about earlier. Now, some other places where we'll use measures will be for ratios, for percent of total calculations, for doing time intelligence, year over year, rolling 3-month total, week over week, month over month, those type of calculations. And also whenever we need to facilitate maybe very complex relationships, it might make more sense just to build the relationship between two tables in a DAX calculation instead of recalibrating your entire data model, right? And so these are all different use cases for writing DAX measures. You can also use DAX to build out calculated tables. Calculated tables are not something that you'll do very often because similarly to calculated columns, if you're going to build a table with DAX, I'd recommend building it further back, not doing it with DAX, build it back in the Power Query Editor, build it back in your SQL database, build it ahead of time as part of your process of loading it into Power BI. However, I've used these calculated tables very often inside of the Power BI model, inside of Tabular, inside of now Fabric semantic models, really to kind of debug and see what the result of that is. However, with some of the improvements over the last few years with Power BI, you can now do that in the DAX query view a little bit easier. And so the focus of this session today is going to be on DAX measures because that really is where you're going to be spending most of your time in Power BI. All right, so what we want to do is we're going to jump right in and we're going to do an introduction into the DAX language, and we're going to start with calculated columns. So let's jump back over to Power BI Desktop. I'm going to open up the file that's in the files that you can download from the description of this YouTube video, and I'm going to start with our data model. I'll open that up and we'll jump right in. So once my Power BI file has opened up, I want to go into the table view and I'm going to create a new calculated column on my customer table. So I'll come over here to my table view, right click on my customer table, and then I'm going to create a new column. And what I'm going to do with this column is we're going to build just a very simple calculation that's going to return the full name of the customer. So we're going to take the first name and the last name, we're going to add that together, and we're going to put a space in between. So we'll call this column full name. And then I'm going to hit the single quote right there. And you'll notice that when I hit the single quote character, I see the customer table and I see all of the columns that are in my customer table. Now notice that the only thing I see at this time is just the customer table. I'm going to come back to that in just a moment. So if I hit tab to autocomplete, that'll bring in the customer, and then I'll hit the open square bracket. I'll start typing first name, that'll pop up, and I can do that right there. So if I hit enter right now, that literally has just created a copy of the first name column, but I'm going to add to this. And so in DAX, I can use the ampersand symbol, which is above the 7, to say, hey, I want to combine two strings together. Then I'm going to do a double quote, space, double quote. So that's a string literal that lets me add a space. So add in everything that's in between the double quote. And then I'm going to do an ampersand sign again. And then I'm going to do the last name. So I'll do single quote and I'll start typing last. And then I will type tab to autocomplete. And so this right here is just a very simple calculation that takes two columns and it combines them together. So I'm going to hit enter. And as soon as we hit enter over here on the right side of our screen, we'll see that we have correctly and quickly combined those two columns together in order to get a full name. Now, this is where I always like to pause for just a moment and make a very obvious statement and say, it's interesting that when we built that calculation that it knew inherently and intuitively to go to that row and to grab the first name from this row. So it grabbed Latasha Suarez. And how did it get the first name and the last name from that row? Like, how did it know to get the first name and the last name from that row? How come it didn't get it from some other row? How come I didn't have to tell it to get it, identify the row in some way, right? And so that's a very basic question. And you would say, well, it does that everywhere else, right? It does that in Excel. So of course it knows to do that. But in the background, in order for this calculated column that I created, in order for it to know to get the first name and the last name from the row that it's operating on, it has to create what's known as a row context. And a row context is very simple. It just means that it's performing that expression on that row. However, there is a side effect of row context that we're going to come back to in just a few moments. And the side effect is that when you're inside of a row context, the default behavior is it can only see the table that it's working on. So we're on the customer table. We created a calculated table or a calculated column on the customer table. Therefore, the row context is on the customer table. So that's why when I first created this calculated column and I hit the single quote on my keyboard and we saw all the tables and all the columns available, the only thing we were able to see is the customer table. We were not able to see any other table in our data model. However, if we go over to our model view, you'll look in here and you'll notice that the customer table has relationships to the fact returns table as well as over here to my fact sales table. So there are relationships in the data model, but when I'm inside of a row context, the default behavior is that it can't see it. And so one thing that you want to start picking up on as you're learning the DAX language is just, I'm inside of a row context. That's why I can't see the other tables that maybe I'm trying to reach out and pull data from. However, I'm going to show you how to fix that in just a few moments when we get to that section, but it's important to introduce you ever so slightly to this idea and this concept of row context. And so there we go. We've created our full name column right there in our model. So now when we're building reports, we're able to slice by the full name and we don't have to bring in the first name and the last name separately. The next thing I want to show you while we're still on the customer table is how we can come in here and build that age demographic. So let's say that we're starting to build reports and we're looking at our sales. We're looking at total sales by country. We're looking at total sales by product. We're looking at total sales by temperature. And somebody comes in and says, hey, we actually want to be able to see our sales and our profit margin. We want to be able to see that by the different age demographics, right? And so we need to build a calculated column. So it's going to help us to describe our data that has different age brackets like 18 through 24, 25 through 34, 35 through 44, etc. And so what we can do is, again, I can right click on my customer table. I'm going to click new column. And now we're going to create a new column called age breakdown. There we go. And there's a couple different ways you can do this within the DAX language, but we're going to use the if function. So we'll say if, and then we'll do customer and then age. So if the customer age is greater than or equal to 55, then we're going to categorize those customers as in the 55 plus bucket. And then what I can do is actually just copy and paste this because I'm going to put multiple different lines here. So I'll do Shift Enter to go down to the next line. So I'm using Shift Enter to go down to the next line. And then I'll paste that code in there and I'm going to say, all right, if the customer is greater than or equal to 45, then the customer is going to be 45 through 54, right? And then I'll do that again. Shift Enter and then I'll paste it using Control V. If the customer is greater than or equal to 35, then we're going to say the customer is 35 to 44. So I'm just copying and pasting it here to make it a little bit quicker. I'll paste it again, and we're going to do 25 to 34. I messed that one up. There we go. And then finally, we're going to say, look, if they don't fit within any of those categories, anybody else who has not been categorized, we're going to put them into the 18 through 24 age group. And then we need to use 4 closing parentheses here, 4 closing parentheses to close that out. And so if I hit enter now, what that's going to give me over here is all of my customers are going to be put into different age buckets. And if I click the drop down, we can see that we have all of the different age buckets accounted for, and this looks good. So basic if then else logic that you would get in Excel, SQL, Python, any other language. So the cool thing about this is you might have noticed that when I did my age breakdown, that 45 is technically anybody above 45. I don't have an upper range here. I don't say if they're greater than 45, but they're less than 55, then they're 45 to 54. I'm just saying if the customer is greater than or equal to 45, then 45 to 54. So that if you're very astute and you're paying close attention here, you might have seen that and you might be like, why didn't you put an upper range? Well, the way that the if condition works in DAX is it uses something called the first pass rule. So when you're looking at 55, any customer that falls within the 55 bucket, they're not going to be available for the next condition. This is important to understand for, both debugging as well as possibly performance on larger data models, right? But that's why we did not need to worry about that. So there we go. So we've done a combination column where we combined multiple strings together. And now we did some if condition logic inside of Power BI Desktop so that we now have some other and additional columns to help us describe our data just a little bit better. Now, the other thing I want to talk about here and I want to dive into is how to maybe format some columns so that it just looks a little bit better on your report. And so if I go over to my date table and I go into my date table here, you'll notice that on the date table, we have a lot of columns. We have columns for year, for month number of year, for month name, etc., etc. But what I actually want to do on this table is I want to have, for my report visual, for my column charts, I want to have month and year. So I want to have the 2-digit month and I want to have the 4-digit year, and I don't have that. So what I would have to do right now is I'd have to actually add multiple columns into my chart, and anytime I build the chart, I'd have to do that, and it still might not be formatted exactly the way that I want it to be. And so inside of the DAX language, we can use a function called format. So I'll go over to my date table, right click on that, and then just like we did with customer, I'll create a new column here. And the column that I'm going to be creating is going to be called month year. Okay, so this will just be my month year column equals, and then shift enter down to the next line. And I'm going to use that format function. So I'll say format, and then you pass in a value that you want to format. So the value that I want to format here is going to be the date column from my date table. So I'm going to use a single quote right there, and then I'm going to hit tab, and then I'm going to do an open square bracket. I'll type in date, and then I'll hit tab again. Now, I'm going to give you a real quick tip. And this is actually something that Nick Lee, who works for us, taught me not actually too long ago, probably a couple years ago. If I hit the single quote and I know I want the date column from the date table, I can actually just start typing out date. Well, this one doesn't quite work that well because it's the same name as the table. But let's say it was calendar quarter. If I start typing out quarter, notice how calendar quarter from that table pops right up. So you could actually get away with that right there because date is the same name. It wasn't really popping up there, but you can just do the single quote, start typing the column name, and it will pop up with that IntelliSense as well, which will let you get there a little bit quicker. Now, what we want to do is we want to format this as 2-digit month. So month dash YYYY. And there is a side effect of the format function. Whatever you are formatting, the result of it will be of type text. It will be a string value. So keep that in mind. But what this gives us is this function gives us a lot of flexibility. So when you do ilm, that's going to give you the 2-digit month. So 01, 02, 03. If you actually do 3 ILMs, it'll give you the abbreviated month. So for January, it would be JAN. For February, it would be FEB. If you do 4 ILMs, it'll give you the full month. So it'll give you January, February, March, spelled all the way out. And so you have a lot of flexibility and versatility with this DAX function. So I'm going to hit enter. And now we have very quickly a month-year column that we can use in our visualizations. So that's just a real quick introduction to writing DAX. Hopefully so far, everything, if you come from any kind of expression or programming background, all of this looks super easy to you. And that is calculated columns. Now, where this can get a little bit tricky is when you want to you want to create a calculated column that needs to communicate with another table in your data model. Because remember, we talked about earlier, when we're working with a calculated column, there is a limitation there. And that limitation is that when you're building a calculated column, it creates a row context that more or less disables the relationships in the data model. So what we can do in order to reactivate those relationships is we can use something called navigation functions. And the navigation functions inside of DAX are going to be related and related table. Now, which one you use really depends on where you're at in your scenario. So if I want to use related or related table, it depends if I'm on the one side or the many side of the relationship. I'll come back to that in just a moment. What related does is related is going to go over to another table and it's going to bring back a single scalar value from that table. So if you're using related, that means you're on the many side of the relationship. You're going to the one side because you're returning a single scalar value. Therefore, it has to be the one side and it has to be a single scalar value. If you're going to be using related table, that means you're on the single side of the relationship. You're on the one side and you're reaching out to the many side. So it means I'm on my customer table and I'm getting information from my sales table where the customer shows up many times. So I'm using related table. I'm on my product table. I'm getting information from the returns table where the product has been returned many times. So I'm using related table in that instance. And so we use related and related table in order to reactivate the existing relationships in the data model when we're inside of that row context. This is actually very similar to if you're working in Excel and you needed to get data from another table. In Excel, you would use some kind of lookup function, right? X lookup, V lookup, etc. That's kind of the purpose that related and related tables serve here. The difference is that you don't have to specify what the relationship is with related or related table because it's already been defined in your data model. Now, if you were in SQL, you would use a join, right? You would say, take this table, join to this table, bring that column from this table over to this table. So that's where related and related table kind of fit in. They allow you to leverage the existing relationships in the data model. Now, keep in mind, if you've written DAX before and you've written a lot of calculated measures, you're probably thinking right now, wait a minute, Mitchell, I've never had to use related and related table. I don't think you're right. Remember, we are talking right now explicitly and specifically about calculated columns and the fact that calculated columns create that row context to where you can't actively or you can't use the active relationships in the data model. They are disabled. So in order to leverage them within that row context, that's when we use navigation functions. So yes, you don't have to use these all the time, but there is a time when they are important, and that's exactly what we're covering in this next section. So now that we have a better understanding of navigation functions within the DAX language, let's tie all of this together with an example. So one of the most difficult things that I find that customers have with Power BI models is figuring out how to bring in data from different locations and how to structure that data and then build relationships between it. In fact, I would highly recommend if you're new to Power BI and you're learning DAX, if you're not familiar with the idea of data modeling in Power BI, that you go take a look at our data modeling video on our YouTube channel. We have a couple of them out there now, and really understand the proper way of modeling data within Power BI, because that makes a big difference as far as how easy it is to write your DAX. If you do not have a well-defined data model, the DAX calculations that you write are going to be much more difficult and much more challenging. So if you're not familiar with that concept of data modeling, the star schema, please take a look at those videos on our YouTube channel. But if I take you over here and we look at our data model, you'll notice that we have this table over here called our temperature table. And what the temperature table has in it is, and notice that there are no relationships right now. So if I go over to my table view and we go over to our temperature table, what this table has is it has the region, it has the month, and then it has the average temperature for that month. So it's to say the northeast of the United States during January is cold. The northeast of the United States during February is cold. So this table has that information. And so now we can take this data, and if we can build a relationship to our sales table and our returns table, we can now do analysis based on the different months of the year, when it's cold, when it's hot, when it's warm, which is different by region, right? So do we have more sales when it's cold, or do we have less? We can now do analytics based on that. However, I can't really build a relationship from the temperature table to the sales table on month, because in this table, month shows up many times, right? We got January, we got January, we got January multiple times. And in my sales table, if we have 27 sales today, that means we have 27 sales in the month of June. And so June shows up 27 times. And so you can't build a relationship on month, right? Because it's a many-to-many relationship. Again, go watch the data modeling class. We don't want to do that. We want it to be a one-to-many. I can't build a relationship on region because we have the same exact problem. Region shows up in this table many times. It'll show up in the sales table many times. And so neither one of those columns is an effective key column for this. What we need is for the temperature table to be the one side of the relationship. So I need a key that makes the temperature table unique. Well, fortunately for us, we already have one. That's what this column right here represents. And so in this table, the combination of the region and the month is 100% unique, so there's no duplicates in this table. Now, the problem is that if I go look at my sales table, we do not have a column that already has the region and the month. So let's go take a look at our sales table real quick right here. So in my sales table, we do have the sales territory key, so we can go to the sales territory table, get the region and bring it over. And we also have the date key. If we go a little bit further over, we have our order date. And so we can use the order date to go over to the date table, get the month and bring it over. And so what we need to do is create a calculated column. Remember, we talked about at the beginning, one of the main use cases for calculated columns is creating a key that allows us to build relationships between tables. So that's exactly what we want to do right now. So in my fact sales table, I'm going to build a new column. So I'll right click on fact sales, build a new column here, and I'm going to call this my temperature key. All right. So this is going to be our temperature key, and then I'll hit Shift Enter to go down to the next line. Now, I know that I can take the sales territory key that's on this row, which was a value of 4, pass that value of 4 into the sales territory table and get the region, right? Northwest, Northeast, Southeast, Southwest, etc. So I know I can do that. So what I would expect to happen, especially if you've been working with DAX a little bit, in this column is if I start typing out, like start with a single quote, and I type sales territory, I would expect sales territory to pop up. But you notice that it does not. In fact, the only thing that I can see when I start typing in my calculated column is only columns that come from the fact sales table. And this is because we're inside of a row context. So by default, the row context disabled the relationships in the data model. So even though there's a relationship between the sales table and the customer table, it doesn't recognize it. So this is where we leverage those navigation functions. Now, we are on the sales table. The sales table is the many side of the relationship. The region or the sales territory table is the one side. So it's a one-to-many relationship. Sales territory is the one side. The sales territory key is unique in the sales territory table. So what we can do is we can use the related function. So I bring in related, single quote, and now notice when I hit single quote now, all of a sudden I can see all of the tables in my data model. I see customer, I see date, I see product, and then of course sales territory. So I'm going to come back over here and type sales territory, and then I'll hit tab, and then I'm going to do region. Now again, this is the trick I wanted to show you earlier that didn't quite work because it was the date table. If I hit single quote and I start typing region, it automatically recognizes the sales territory region. Now, another tip, so that's tip number one. I'm gonna give you a couple tips here back to back. So if you do single quote, start typing out the column, it'll actually recognize the table and the column name. I hit Control on my keyboard, and then I use the mouse wheel to scroll in and scroll out to make my formula bar bigger. However, when you do that, so that's tip number two, when you do that, it makes it hard to read the IntelliSense right here. So what you can do, tip number three, is you can actually make this box bigger as well so that you can see everything just a little bit better. So these are all little tips and tricks that I like to do. Even when I'm writing DAX on my own, I like to make that formula bar just a little bit bigger so I scroll in like that. And so now I type in sales territory region and I hit close parenthesis. And if I hit enter, it's going to give us the region. It's going to bring it up. Now I want to point out one more thing. You'll notice that I'm still getting a warning on the bottom of my screen. So earlier when I was showing you how to find region, I accidentally hit enter or accidentally clicked a button and it tried to evaluate the code. It tried to validate the code and it failed because I wasn't done. So I got an error message. I've fixed that. I've ratified that. I've made it so that it is now whole and it is working correctly. However, if you're new to DAX, this warning message right here implies that there's still something wrong. And so I've seen people that are brand new to DAX literally fix the problem and not hit enter or not click the checkbox because they didn't realize that this is not an up-to-date thing. So in other words, I fixed it, but that message at the bottom is not updating to say you fixed it. So if you want to validate, you can come over here and commit that change or hit enter and then verify that it worked. So now if you look at our temperature key column all the way down, we have brought the region in from our sales territory table, and we have all of the applicable regions available. Now, this is still missing something, right? We are still missing the month number of year. And so we need the month number of year from our date table. So if you remember from our example earlier, when we did the full name, first name, ampersand sign, last name, we now need to use our ampersand character. And then we need to bring in the month number of year from our date table. However, if I just type single quote and type date, we have the exact same problem that we did before. We're still inside of the row context, so it can't see the date table. So even for the date table, I have to also come over here and use the related function. And then when I start typing out, month, I can see the date table and I can grab the month number of year. So I'm going to hit tab to autocomplete. And then I'll close parenthesis, and then we'll hit enter again, or you can click the little checkbox in the top left to commit your changes. And so we're going to go ahead and hit enter here. All right, so now we have our temperature key here, and the temperature key already existed on our temperature table. So what we can do is I can go back over to the model view, and we can build a relationship now from our temperature table over to our fact sales table. So I'm going to expand my fact sales table. I'm going to find the temperature key that we just created, and I'll build a relationship from my key column to my temperature key by just dragging and dropping that relationship right there. And there we go. This will kind of validate, hey, this is going to be a one-to-many. This temperature table is the one side. The fact sales table is the many side. It's going to be an active relationship, and we're only going to be filtering in one direction, which is from the one side to the many side. Everything is perfect, exactly the way we want it. So we're going to click save. And so now we have this relationship that we were able to build. And again, this is one of the biggest challenges that I see customers really struggle with, is they're bringing in data from different locations, right? Because we all have disparate data sources all over the place. They're bringing it into Power BI, and they don't know how to build the relationships so that all of the filtering and the magic that happens within Power BI works the way that it should. And so being able to build these columns to build those relationships is a really big part of that. All right, so that right there brings our data model into its completeness. The next thing I want to talk about here is focusing a little bit more on this idea around row context and those navigation functions to do some more analysis. And so for example, if I wanted to know on any of my dimension tables like sales territory or product or customer, if I wanted to be able to categorize a customer or a country by their volume or their amount of sales, then what I would need to do is on the sales territory table. So if I come over to my sales territory table, for example, let's say that somebody calls us up and they're like, hey, I love the model, but we need to be able to do analysis based on, we want to be able to compare all of the products that are high volume. And we want to be able to look at the profit margin of high volume products, comparing them to one another. So I don't want to compare a high volume product with a low volume product, right? I want to compare all the high volume products with other high volume products for profit margin. Well, in order to do that, on my sales territory table, I need to have a column that says this is a high volume or a low volume. So I say Northwest is high volume, Northeast is low volume, et cetera, et cetera. Now you can obviously just type that in, but that's not really ideal. What we would rather do is build a column on this table that is going to facilitate that and have the correct information. And so if I go over here to the model view, just to show you this real quick, let's say that we were to get rid of year, and then I go in here and I grab my sales territory and I bring in region. Let's do this by region. So I bring region in, right? And so we have all of these regions. And then I come over here and I go into my sales table and I grab sales amount and I drop it in there. So now we can look at this information and we can find out, is this a high sales region or a low sales region? So we would say Australia, Southwest, Northwest, all of those, maybe even United Kingdom, all of those fall into like a high sales or high volume region. But then we would look at Germany, France, Canada and say that's medium. And then obviously the other regions there at the bottom, we'd say, okay, those are low volume regions. And so in order to do this calculation in the table, we have to first get the sum of sales for each region, and then we can build that column. All right, so if I go back over here, I'm going to create a new column that does the sum of sales amount from the sales table. So we'll right click on sales territory. I'm going to build a new column, and I'm going to call this column here just sales, region sales. And then I'm going to go to the end, shift enter down to the next line, and we're going to say, all right, we want to do a sum. So sum from the fact sales table, and I want to sum up the sales amount, just like that. Now, when I hit enter here, it's going to give us some really odd results, right? When I hit enter, it's going to duplicate the results all the way down. And we know as soon as we see that something's not quite right. That is not what we're looking for here. What we expect it to do is give us the actual region sales for each region. We just looked at it in the other screen, and Australia was like 9 million, Northeast was like 5 million, etc. So these numbers are not quite correct. So anytime you're working in Power BI and you see this duplicated value like this again and again and again, that means that there's a problem with the relationship. Either the relationship doesn't work, or the model, your DAX calculation, isn't using the relationship the way you thought it would, or there's a problem with that relationship, right? There's something going on with the relationship. So whenever I'm helping a customer and I see this occur immediately, I'm like, okay, let's look at the data model. Let's look at the relationships. Let's dive into that. Now, we know why this is happening, because when we do sum of sales amount, if we're inside of a row context, which we are because it's a calculated column, if the relationships in the model are deactivated, which they are because we're in a row context, then it's going to the sales table unfiltered and it's summing up everything in the sales table. So what we expect it to do inherently, if you've ever worked with Power BI, like it did in the report view just a moment ago, we were looking at that table, everything was filtered exactly like it should be. That's what I would expect to happen here, but it didn't happen. So you say to yourself, well, why didn't that happen? Because the filter for this sales territory key of 1 did not get passed into the sales table. So we're not looking at region sales for sales territory key of 1. We're looking at sales for every region because there is no filter. So we need to turn on that filter. Now, there's a few different ways to do it. One is a little bit more complex and more advanced. So let's stay with navigation functions. And so what we can do here is, instead of doing that, I can use related table. Now remember, I know that sales territory key of 1 shows up many times in the sales table. So it returns a table of results. So related table is going to return fact sales, and then I can do that. Now, if I hit enter, this is going to fail because this is a table expression This is all of the columns and all the rows for sales territory 1, sales territory 2, depending on what row we're on. But what we can do is we can validate this before we go any further. And so one of my validation tips that I like to use is I like to, whenever I'm using an expression that returns a table, to verify that the filtering is working like it's supposed to, I like to just count the rows in that table. So I'm going to count the rows that are coming from this related table to fact sales. So I'll hit enter to count the rows of the table, and we see that the number is different. It's not duplicated all the way down. That is a great sign. That means that the filtering has now been enabled because of that navigation function. And to take it just a step further, I'm going to grab lines 3 and 4. I'm going to hit Control// on my keyboard to comment that code out, just to show you what it would have been unfiltered, because we're inside of a calculated column. We're inside of a row context. If I just count the rows from fact sales, it's going to be the same number all the way down. It's going to be 60,398. So this is an unfiltered table. But by using related table, so I'll uncomment that code. By using related table, we are saying, hey, there's a relationship that exists in the data model. I know I'm in a row context, but take that filter that's on this row and pass it through to the sales table. And that's exactly what it does. And so this looks great. Now, if I just wanted to know number of transactions, this is it. We're done. We're good to go. We can see the number of transactions, and we can see Australia has 13,000. We can see that the Southwest has 12,000. We can see those numbers right there. But we wanted to take it a step further. We actually want to get the sum of the sales from that related table. And so now we get to talk about my favorite functions in all of DAX, which are X functions. And so we're going to break this down. So instead of using count rows, I'm going to get rid of count rows and replace it with a function called SUMX. Now, if I try to do sum, you'll notice that when I do sum here and I do open parenthesis, if we read the IntelliSense, it says sum column name. So the expectation of your basic aggregate functions like min, max, sum, average is that you pass in a column name and only a column name. So the problem that we have here is that because we used related table returns a table expression. So I can't use sum on top of a table expression. And this is going to be something that you run into as you continue your DAX journey again and again and again, because you're going to be doing a lot of table expression manipulation where you first filter the table, or you use calculate table on top of it, or you do this or you do that. And so you're manipulating the table in some way. And then after you've manipulated the table, then you want to perform some kind of aggregation on top of it. And the default aggregation functions don't work. So what we do, very simple, is we use SUMX. And so I'm going to say SUMX over the related table. And what I want to sum up here is I want to sum up the fact sales amount. All right. The X portion of the X function is, and I'll type this out here, going to perform an expression on every row of the table. Okay? And effectively, it returns a one-column result. All the time, every time, the X portion is going to perform an expression on every row of the table and returns a one-column result. And so just focus on the X portion right here. The X portion is going to work over the related table, fact sales, and for every row, it's going to return sales amount. And so if you think about Northwest region, the Northwest region has 8,993 rows over in the sales table. But let's just think about one that's a little bit easier here. Let's look at Central. So the Central region has 20 rows. The Central region is sales territory key of 3. So let's visualize this for a minute. If I go back over to my sales territory table and I filter it down, or actually the fact sales table, if I go to the fact sales table and I filter this down to sales territory key of 3, we're only going to see 20 rows. These 20 rows of data are the exact data that the related table function is returning, right? So we did from the sales territory table, remember we did count rows, we did related table to the fact sales table. So it passes in the sales territory key of 3 into the fact sales table, and it only returns these 20 rows for sales territory key of 3. And then we're doing, over that related table, we're using our X function. And what we're doing with the X function, we're saying, hey, this table has all these columns and it has all these rows. But what I want the X function to do is from every row of that table, I want to return the sales amount. So it's going to go to the first row and return 229 and then 539 and 24, 34, etc. And it's going to return all of those results. Now, as part of that expression, we could do something more advanced. I could say take sales amount, multiply it times quantity. I could say take sales amount, subtract tax amount, or take sales amount, add tax amount. Like you could perform an actual expression in there other than just returning sales amount. But when it's done, when the X function is completely done, it's going to return a 1-column table that looks identical to what we see right here because all we're doing is returning sales amount. And so let me go ahead and clear that filter, and then we'll go back over to our sales territory table, and you'll see that we're getting all of our results. But let's go back into here and talk about this. So the X portion, and I like to think of X functions as 2 separate distinct operations. The first part is going to perform an expression over every row of the table that you pass in. So we're passing in that filtered sales table, and it's going to return a 1-column result. And so for the Northwest region, it's going to wind up having about 8,993 rows and 1 column that has all the sales amount. So that's the first part. Now, the second part of the X function is the aggregation, right? Whatever that aggregation might be. It might be SUMX, might be MinX, might be MaxX, might be AverageX, could be multiple things. So if we do MinX, what MinX would do is it would look at that 1-column table that had those 20 rows that we were looking at for that one region, and it would find the minimum sales amount, right? It'd look at the whole column, it'd find the minimum, the least. If I did MaxX, it would look at the whole column, it would return the max. If I do SUMX, it's going to go down the column and sum everything up. AverageX would get the average. And so X functions are going to work exactly like your normal aggregation functions. The difference is that we first need to kind of create that column. So we create the column, then we can do the sum, the min, the max, the average on top of it. So 2 separate operations. Aggregation performs the specified aggregation. Let's make sure we spell this correctly. Aggregation on top of the column returned by the X expression. And that's the way I like to think about it. It helps me to understand it. I absolutely love X functions. They're my favorite functions in all of DAX. And so when we hit enter here and we go down to the bottom, we can see that the region sales that get returned are in fact correct. And we can kind of validate and verify that back in the report view. And so I'll go ahead and close this out, and then we'll look at our results. Now, remember, we would never, ever, ever build a region sales, a region quantity, region transactions, calculation, and a calculated measure. Let's be very careful with that. The only reason that we did the sum in this column instead of in a measure is because we needed the sum so that we can then create the other column that tells us if it's a high volume, a low volume, medium volume region. Otherwise, you should always be doing these sum calculations in a measure. We're going to be spending most of our time today inside of measures once we wrap up this section on calculated columns. And so now that we have this region sales, I'm going to go over to my sales territory table, create a new column, and the column that we're going to create is going to be called, let's call it region sales volume. All right, region sales volume. And now we're going to do an if statement. Inside of the DAX language, you can use if. You saw earlier when we used if, we had to do a bunch of nested if statements with like 4 closing parentheses. We can also use a function that's a little bit easier when you have multiple different conditions, and that is the switch function. So I can do switch. That was the wrong thing. Let's try that again. Switch, there we go. And I'm gonna do true, and then we'll go down to the next line. If you want to understand why you actually pass true into this expression, this is not the way the switch function was initially built and designed to work. Rob Coley at Power Pivot Pro has a really great article he wrote, I don't know, 10, 12, many years ago about this pattern and why it works. And so I would encourage you to go find that and read that. It's a really great article. But what I'm going to do is I'm going to say, all right, switch true. And then I'm going to say when my region sales is greater than or equal to, and we can always move this around, but we're going to do 3 million. So I'll type that in. When it's greater than or equal to 3 million, we're going to say it's high. And when I'm going to hit escape there. When the sales territory is greater than or equal to 1 million, we're going to go with medium. And then if it doesn't match any of that, actually we have an NA, so we're going to take it again. I'm going to say when sales territory region sales is greater than 0. And then we'll say if it doesn't match any of that else, we're going to go with NA. NA being for the NA row that we have here at the bottom. All right. And so then we'll hit enter, and that gives us our switch true statement. So again, remember the reason that we built the column was really for 2 reasons here. One, to introduce you to navigation functions and show you how to use an X function, but also because we needed to create this column. Now there are other ways of getting to this column without having to create the calculated column. We could have used a measure inside of this expression, but just keep in mind that my big thing to warn you about is you should very, very rarely be creating any kind of aggregations inside of calculated columns. Very, very rare. If you're creating an aggregation, your default mindset should always be, hey, I'm just going to build it in a measure, and then I'll pass it in to the calculated column. But creating this calculated column allowed us to emphasize on row context, also how to use an X function, and then also some of the limitations with calculated columns. So there we go. So let's do another example while we're on this, just to re-emphasize again this idea of row context and X functions. So another example, and there's a few examples we could do here, but another example that I like to do is on my customer table. If we look at our customer table, we'll have something like the date of their first purchase. So we can get the customer's first purchase date. But what if we want to know the last purchase date of a customer? What is the last purchase date of a customer? If you're looking at Mitchell and you want to know my last purchase date, you would go to the sales table. And on the sales table, you would say return max order date for that customer ID, whatever it is, right? So you'd filter down to my customer ID, 11,000. And then you'd say order by, sort by order date descending. And then you'd look at these, that's the last order date. But if we needed to know the last order date because we're trying to figure out how long has it been since a customer made a purchase or whatever it is for marketing reasons, then how do we get that information? And so what I can do is I can right click on my customer table, create a new column, and then we're going to create our last purchase date, right? And then we'll do equals. Now again, we're inside of a calculated column, which means we're inside of a row context. So even though there is a relationship between customer and sales, if I start typing out fact sales, it says, it doesn't know what we're trying to do. It doesn't work, right? Because that relationship has been disabled. So because we're on the one side of the relationship and the fact sales is the many side, we're going to use related table, right? Related table. And we're going to go over to our fact sales table and we're going to close parenthesis. So this is going to give us a filtered table. And then what I want to do is I want to get the maximum order date. Now, of course, we know that if I just type max, it expects either a column name or a series of scalar values. Like if I were to say max 10, 12, close parenthesis, it would return 12, right? If I were to pass in scalar values. But it doesn't let me pass in a table expression. Related table is a table expression. So it doesn't work. I can't use max. So we have to use max x. So I'm going to use max x. Now the first portion of an x function is going to go over every row of this table, one row at a time. And what do I want it to do for every row of the table? I want it to go to the first row and I want it to return the order date. And then I want it to go to the next row and return the order date. And I want it to go to every row from that related table that's been filtered by the customer that I'm looking at and return all of the order dates for that customer. So when I'm looking at Mitchell, go to the sales table, get all the order dates for Mitchell. So that's what the X function does, right? That's the first distinct operation. Return a one column table that has all the order dates for each customer. And then I can get the first purchase date by using min. I could get the last purchase date by using max. So that's where we do the aggregation, that separate, distinct operation. And so if I use max X, it's going to look at that list of order dates, and then it's going to return the maximum date. So I'll hit enter, and then we'll come over here and we'll see that result. And so just another example of using an X function on top of a related table. Now I'm showing this inside of a calculated column because in a calculated column, it's easy to visualize exactly what's happening with what we're doing here, right? So I'm able to visualize that, hey, if I were to do, right, let's do this real quick. I'm going to shift enter. I'm going to grab everything here and do control / to comment that out. If I were to just do max and then do fact sales order date like this. So a lot of people that are new to Power BI, new to DAX would try to just do this. If I do that, watch what happens to the last purchase date column. The value is duplicated all the way down. All the way down, it's duplicated, right? And you ask yourself, well, why is that happening? Because there is a relationship that exists between these two tables that's not being used. And it's because we're in a calculated column, and it's because the row context has disabled that relationship. And so as soon as I see that this is an issue here, I can go back and I can do this. So this is something that you're going to deal with outside of calculated columns. Row context does exist outside of calculated columns. The reason I show it and the reason I teach it right here is because it's easy to visualize, because we can immediately see, oh, that's wrong. If you were doing this inside of a measure, you can't really visualize it because the measure returns a scalar value, a single value. So this allows us to visualize what's going on. So I'm getting a duplicated value all the way down. That doesn't work. So then we say, oh, I know what I need to do. I'm going to use related table to filter it based on the existing relationship. And then we'll use max X to return the last order date for that customer. And there we go. So now we have the last purchase date for each customer. And now we can do some analysis on this. Maybe you compare the last purchase date to today's date to get the number of days since the last purchase. And then we have some actionable data that we can make some business decisions on. Do we send them a marketing campaign? If it's been more than 60 days, do we do this? So now we can do some really cool stuff with this data. All right, so now we're going to jump in and we're going to talk about calculated measures. And we're going to spend the majority and the rest of our time as we're talking about DAX until we get to visual calculations and Copilot. But even with that, we're going to be kind of talking about measures. We're going to spend the rest of the time talking about calculated measures so that we can do some of that advanced analytics that we want to do within Power BI. And so within calculated measures, we're going to talk about different aggregations that we can perform. We're going to talk about filter context. We're going to dive into time intelligence. And then we're also going to cover the most important function in all of the DAX language, which is the calculate function, and make sure that you have an understanding and a grasp of how to at least introductory, how to use that calculate and understanding why you're using it. Because I work with a lot of customers, and when I see them using calculate, they don't understand why they used it. They just found it on Copilot or on some forum, and they're not quite sure why they're using it the way that they are. And so we'll kind of talk about that and we'll discuss it in this section. So when we're talking about filter context, and I'm going to talk about this a lot over the rest of this session, filter context is the filters that are automatically applied within your data model. So all of filter context, for the most part, with very few exceptions, all of filter context is based on and predicated on the active relationships in your data model. So when you bring in a report visual like a chart or a table, and you start to filter that chart by the year, by the country, by the customer, by the date, whatever it is, and it just changes automatically. The reason that measure is changing as filters are added from different tables is because of those active relationships in the data model. So those active relationships in the data model are really the base and the foundation of filter context the way that we know it, okay? So that is really the introduction to filter context there. So in Power BI, I'm going to go back over to my report view. And in the report view, I'm going to go over to my sales table, and I'm going to go ahead and start building some measures. Now, one of the very big and distinct differences between a measure and a column is that when you create a measure, the value of that measure does not show up in the table. So building that measure over in the table view, like we did with our calculated columns, really doesn't give us a way to validate it. So I just usually will create my measures right here in the report view so I can then put them into a visualization and validate and verify that they're doing exactly what I want them to do. And so in this report visual right here, I'm going to get rid of sales amount, and we're going to go in and we're going to quickly build just some basic measures. And so this is going to be easy. This is going to be relatively quickly. Now, the other thing I want to point out is that in your class files, there is a document in there for the DAX code examples that I'm using throughout this course today. And so if you are in the class files and you open up that text document, you'll have all of the code that I'm using. And if you get behind or if you're having a problem with your code, you can just copy out the DAX from there and you can paste it into the formula bar in order to make sure that you don't get too far behind as we start to write more complicated DAX in this section. And so what I'm going to do is I'm going to jump over to my fact sales table. I'll right click on that and then create a new measure. And then the first measure that I want to create is going to just be total sales. All right. And so I'm going to create a measure called total sales. And total sales is going to be the sum of internet sales or fact sales. There we go. The sum of fact sales, sales amount. That's it right there. And so I'm going to hit enter. And then one thing with measures is as we create them, we want to make sure we format them. So I'll come over here and I'm going to tell it I want to go with English United States. So that's the currency format that I want to use. And then I'm going to go ahead and add this measure into my report. And so right now I have region. I'm actually going to get rid of region, right? Let's get rid of region and then let's bring in total sales. And there we go. So total sales throughout my entire model is $29,358,677.22. That is total sales. And so that is total sales for all customers, for all dates, for all temperatures, for all regions. That's across everything because right now we have no filters that have been applied, right? But if I add a filter, so if we said, all right, I want to take a look at this based on, let's say, year, and I add years into the rows, you'll notice that I'm now getting a breakdown of my sales by year. And the reason that that works is because of the active filters within the data model. In order to maybe prove that to you so you can see that, if I go over to my data model and I go to my date table, there's a relationship right here between date to order date. If I delete that relationship and it goes away, when I come back over to my model view, you'll see the numbers are being duplicated all the way down. And the reason they're being duplicated is because it's getting the sum of sales from the sales table, but it's not being filtered by the date table because there is no active relationship, right? And so by simply turning on the relationship right here from my order date to my date table and then clicking save, that is going to allow the automatic filtering that occurs within the DAX language to occur. So let's go back into our total sales measure for just a moment. And let me take a look at this again. And so when I'm teaching this, so we do here at Pragmatic Works, we do a full week DAX boot camp. So if you're watching this session today, as you're going through it, you're like, man, I'm learning a lot from just this 3-hour session. I really want to dive deeper. Imagine how much you would learn if you spent an entire week with one of our experts here, just writing and working through DAX and having somebody to just talk to and have conversation. And the other thing that's really cool, if you want to meet our team, we just moved into a new office and we actually are doing in-person live boot camps again. So you can come to our office and spend a week with us and really dive deep into the DAX language. And so when I'm teaching DAX in one of those boot camps and I'm going through this with students, one of the things that I talk about is how to define a measure. And so when I'm looking at this measure right here, and I ask somebody who's going through one of those classes and it's live and we're able to interact with one another, I say, how would you define this measure? So I'm looking at the measure right here, the sum of sales amount. How would you define it? And what most people will say is that's the sum of sales from the fact table. And although that is correct, it's not complete. Okay, it's correct, but not complete. The way that I would define this is really something, and I'm going to comment out the code by using the /, is I would say something like, this is the sum of sales amount from the fact table, from fact cells. Let's just do it like this, from fact cells within the current filter context. And to take that a step further, I'm going to define filter context. Keep in mind, filter context can be very involved and very complex, but the basic fundamental working knowledge of filter context that we need is this. So filter context is active, or let's do this, filters that are applied through the active relationships in the data model, okay? So when I'm defining this measure, my definition of it is it's the sum of sales amount from the fact cells table within the current filter context. Well, Mitchell, that's complicated. What do you mean current filter context? Well, filter context is within the any filters that have been applied through the active relationships in the data model, like we just did. So when I add in year, there's an active relationship between the date table and the sales table. So it filters it down as I would expect. And so that sales amount measure is very dynamic. It's dynamic to whatever filters that we apply. And all of the measures that we're going to build in this section are going to be directly tied, to this definition of respecting the current filter context. Now, later on, when we get to calculate and time intelligence, we're going to be doing something a little bit different. We're going to be changing the filter context, which is where you really spend most of your time. All right. So we have our total sales. That looks great. We're going to go through and we're going to build a couple more measures real quick here. So on my fact sales table, we're going to build a new measure here. And this measure is going to be called total cost equals shift enter. And then we're going to say we want to do the sum of, from our fact sales table, total product cost. All right. So for our total cost, it's going to be the sum of total product cost. And just like our total sales measure, this is going to be the sum of total product cost within the current filter context. So it respects all of the filters that are being applied through the active relationships in our data model. So we'll hit enter on that. And then I'll come up to my currency here and I'm going to do English United States. And there we go. So that looks good. So let's do a couple more real quick. I'm going to do one for quantity. So I'll do a new measure. And this measure is going to be total quantity. And my total quantity is going to equal the sum. And then if I start typing quantity, you'll see it pops up. So I'm going to go with fact sales order quantity. And again, very simple calculation. This is going to be the sum of order quantity, and I'll hit enter. All right. And then this one is going to remain a whole number, but I do want to add a 1,000 separator right there. So I'll do that and then enter. All right. So we have total sales, total cost, and then we also have total quantity. The other thing that we might want to get here is maybe we want to know the total number of transactions. So for example, if I'm looking at 2022, how many orders did we have in 2022? How many orders did we have in 2023? And so if I look at my fact sales table and I look at this table right here, you'll notice that in our table, we have sales order number and we have line number. And so it's very important to understand what a row represents in the fact table. And so in our fact table, one row represents a line item on an order. So the order can show up in this fact table multiple times, right? If there's 10 line items, the order number would show up multiple times in this fact table. And so that's important because if we're counting total number of orders, which is the sales order number, then what I can't do is just count. So let's do that real quick. So we're going to build a new measure. The new measure that we're going to build is going to be called total transactions or total, let's go orders. Total orders equals, and then I could do something like either count or I could do count rows. And I could just count the number of rows in the table that's been filtered within the filter context. So for 2022, filter down the fact sales table, show me all the rows for 2022, and then count those rows. However, that would give me the incorrect number for orders because I'd be counting the line items within a number, within an order. So like if I go to the store, Mitchell goes to the store, I buy 5 items, I would have 5 entries on that fact table. So if I just count rows, it would say I have 5 orders. It wasn't 5 orders, it was 1 order that had 5 items. So count rows doesn't really work in this use case. So what I want to do instead is I want to do distinct count. So I can do a function called distinct count, and distinct count over the sales order number will count the distinct number of sales order numbers within the filter context. So I can go distinct count, and then we can go over to our fact sales table, and then we'll do sales order number like that. And so this will give us our actual number of orders for each year, for each product, for each customer, based on whatever filters we're applying. And so again, this measure is working within the filter context. We haven't changed the filter context in any way. We haven't modified it. This is going to respect all the filters that are applied within the model. So if I take total orders, and let me go ahead and hit the 1000 separator, and I add that into the table, we'll see that it's automatically being filtered based on the filters that have been applied. Now, the only filter that's been applied, this is another tip. If I click on this little funnel icon right here, and I love that Microsoft added this, if you click on it, you'll be able to see if there's any other filters that are impacting this visual, and there are not. The only filter that is being applied currently is this year. But sometimes I'll be working with a customer, helping a customer out, and there's something not quite working correctly, and they have some hidden filter that's been added in the filters pane or through some sync slicer or something else that they don't realize is active. And by clicking on this funnel icon, it shows us, oh, the reason the numbers are off is because there's this other filter being applied. Let's go take care of that. And so this is our total orders, which is 27,659. Now remember, there's 60,000 rows in that table, but there's only 27,000 order numbers, which is exactly what we were looking for there. All right, so now if I get rid of that, we want to go ahead and build a couple other quick measures. The next measure I want to create is called profit. Now, profit is, generally speaking, the general definition, sales minus cost, right? So if I go over to my fact sales table, I can do new measure, and this is going to be called profit. We can go with total profit to match our other measures. So we'll go with total profit, and then I have a couple of options here. One, I could type sum of fact sales amount minus the sum of fact sales total product cost. However, we've already created those measures. So one of the benefits of creating your own calculated measures is that we can reuse them, and it makes the code easier to read, easier to understand, easier to debug. And so instead, I could do a open square bracket. And when I do open square bracket, I'm going to see all the measures in my model that I've already created. So I can go down and grab total sales, and then hit tab, and then hit minus, and then I can go ahead and grab my total cost. And there we go. So now we're going to have our total sales minus our total cost. And that's going to actually give us the difference between the two, which will give us our profit. So I'll hit enter on that. And then we do want to go ahead and format it as English currency United States. And just to verify where we're at so far, I'll add in total cost, and then I'll add in total profit. And just doing a real quick eye test, we can verify and validate that all of that looks correct. Now, the next thing that I generally like to create here is some kind of profit margin. And we talked about creating ratios, creating percent of totals. Those are things that you're going to be doing very, very often when you're writing DAX. And so I want to build a profit margin, right? I want to know by customer, by product, by year, by country, how is the profit margin? Which ones are a larger profit margin? Which ones are maybe, leads for getting more sales and getting people into our business? And so profit margin is taking the profit and dividing it by the sales to figure out what percentage of the sales is profit. So we're going to create a new measure here. And the measure that we're going to be creating is going to be called profit margin. And then I'm going to use divide. I don't use the divide operator. What the divide function does is it gives you the ability to safely handle divide by zero case. So if there's a situation where you were going to divide by a 0 and that creates an issue, this handles it safely and just returns a blank value. So I use the divide function anytime I want to do a division operation inside of DAX. I'm going to pass in my numerator. And remember we said we're going to divide the profit by the total sales. So total profit is going to be my numerator, and then total sales is going to be our denominator, right? So we're going to take total profit divided by total sales to get that percentage. And then with that, we can click on this percentage icon right there. We want to make sure to continue to format our measures. And since we already have sales cost and profit in our visual, we'll go ahead and add in here profit margin as well. And there we go. So now we can see our profit margin, our profit, cost, and sales for each of our years. Again, all of the measures that we've created here are going to work with any active filters that exist in our data model, right? So I could take year and move year to the columns. And then what I'm going to do next, let's get rid of cost. Let's get rid of profit margin. Let's get rid of that. So we'll just put sales here. And then if I come over here and I do something like, let's say country. So I grab sales territory country and I drop that on the rows. What we see is that the filtering still works, right? So when I'm looking at right here at that intersection of the year 2022 in Australia, 1.3 million in sales, that is being filtered by both Australia, the country, and the year. So that total sales is respecting the filters, all of the active filters that are being passed in inside of the data model, right? So just kind of re-emphasizing that those active relationships in the data model, all of those combined make up the filter context that our expressions and that our measures are being evaluated within. So now we're going to dive in and we're going to talk about the most important function in all of DAX. And that is going to be the calculate function. So we talked about filter context, and filter context, just like row context at its core, is very simple. It is very simple. It's filtering that occurs automatically based on the relationships in the model. Now, that's our basic working definition. We know that over time, we'll refine that definition and we'll add to it. We might even subtract to it. And when you've been working in DAX for 5 years and you've become an expert, your understanding of that's going to be a little bit different. But for most people, that basic fundamental understanding of filter context is filters that are applied through active relationships in the data model is sufficient, right? Now, most often when you're writing measures, you're going to actually be writing expressions that are taking from or adding to or modifying that filter context. So there's a default filter context that exists within your data model, right? Within DAX. But sometimes we want to change that filter context. So we want to say, all right, I see that I have total sales by country. So I have my total sales, there's a filter on country, so it's automatically filtering down total sales by country. But now I want to be able to get my total sales for all countries. But every time I add total sales into the visual, it keeps filtering it down by country because of that active relationship. And so how do I fix that? How do I get the total sales within the filter context, but get a different total sales measure that modifies or changes the filter context in some way? And that's why calculate is such an important function, because once you understand it, you can use it to modify the default behavior in Power BI to do more advanced things within the DAX language. And so that's what we're going to dive in and talk about here. We use calculate to do things like percent of total calculations, to do ratios, all of our time intelligence year over year, year to date, all of that is either implicitly or explicitly using calculate. Whether you see it or not, all of those expressions are using calculate effectively. Either we're defining it or it's happening in the background. And so let's dive back into our Power BI model and let's go through a couple of real quick examples of using calculate to modify the filter context. So I'm going to jump back over to Power BI. I'm going to clean up this matrix just a little bit for this next section. So I'll get rid of the year. I'll get rid of total sales. I'll go ahead and just leave. Actually, you know what? I'm going to add total sales back in here. There we go. All right. We're going to add total sales right back in here. And there we go right there. So the first measure I want to create is I want to create some kind of percent of total of Australia to the total down here. So 9 million divided by 29 million. I want to build that percent of total. So that means I need to divide the total sales for Australia by the total sales for all countries, right? And so that's what I want to accomplish here. So let's talk about how we do that. I'm going to, for this example, I'm going to build a new measure. So we'll build a new measure here. Now, one of the things that I do when I'm teaching DAX Bootcamp or I'm doing some kind of workshop for a customer, one of the things that I'll do is I'll ask the customer to write out what you're trying to accomplish, because that helps you to write your DAX, as you're going to see here. So for example, let's call this one total sales all countries, okay? So total sales all countries equals. And then before I even get started, because a lot of people get stuck just getting started, before I get started, let me just think through what this is going to be. So I want to return, so return total sales for all countries, right? Like that's what we're trying to do. We want to return total sales for all countries. And so the cool thing about writing it out, if you'll just write down a list of what you're trying to do and what you're trying to accomplish inside of your measures, a lot of times the sentence that you write will actually be the structure for the DAX calculation that you're going to build. So for example, I'm going to say calculate. And so we're going to use the calculate function. You're going to know that you need the calculate function once you realize that you're trying to change or modify a filter context. So the filter that's being passed in is Australia, it's country. I want to get total sales for all countries. That means that if there's a filter on country, I need to change it. I need to modify it. So therefore, we have to use the calculate function. So I'm going to use calculate here, and then I'm going to return total sales. And then we get to the filter portion of calculate. So when you're using calculate, the expression is, generally speaking, the easiest part, because when I'm doing an expression in calculate, it's always a measure I've already created. So calculate total sales, calculate total cost, calculate profit margin, calculate year-to-date sales, calculate prior year sales, whatever it is, I'm just going to pass that in. So now all I have to figure out is, how do I add a filter? So what is the filter? The filter is the filter that I want to apply to my expression. So inside of Power BI, so far, we know that all of the filters that are being applied are through active relationships in the data model. However, we can add our own filters. And the filter that I add takes priority and precedent over the filters that are happening automatically. So for example, if I say all, and then I type in sales territory country here, what I just did is I said return total sales for all countries. Now, if we break this down and look at the sentence that we did at the very beginning, return, calculate, total sales for all countries. All countries was our filter that we wanted to add into the calculate statement. So all countries is exactly what I put down there in the bottom. And so by breaking down the sentence that we wrote at the beginning of what we're trying to accomplish, we can actually use that sentence to write out this calculate expression to modify the filter context. And so what I'm doing with this measure is I'm saying calculate total sales for all countries. And so therefore, because I'm telling it to return all countries and to calculate total sales for all countries, if there is a filter that is happening within Power BI Desktop on country, it is going to override that filter. So for example, if you look at this matrix right here, there is a filter on country. So if I hit enter, and then we format this as English United States, and then we add that right here, you're going to notice that we get 29,358,000 all the way down, because our calculation says calculate total sales, return total sales for all countries. So even though there is a filter on country, our measure is explicitly saying, no, we don't want to use that filter. We're going to return all countries. And so this is the power of calculate. The power of calculate is that we're able to either change, add to, or modify the existing filters that exist within the data model, right? And so that's what we just did in this example. Now, this is the hard part, because if we want to get a percent of total calculation of Australia to all countries, the first thing we have to figure out, which is the hardest part, is how do we get total sales all countries? Well, we now have it. So if I want to get a percent of total calculation, The percent of total calculation is simply total sales divided by total sales all countries. Total sales within the current filter context, remember that's what this is, total sales, the sum of sales amount within the current filter context, divided by total sales for all countries, explicitly defining that we're going to return all countries regardless of if there's a filter on country or not. And so if I go over to my fact sales table and I create a new measure, what I can do here is I can say I want to return a percent of total calculation. So percent of total sales. I would generally name this a little bit better because you'd have a lot of different percent of totals. So you'd have to say percent of total sales by country or something like that. But we'll go down here and do divide. And then we're going to divide our total sales within the current filter context by total sales all countries. So we'll do that. We'll hit enter. Again, feel free to leverage the DAX code document that was provided for you, or pause the video so that you can type that out. I use IntelliSense. So a lot of times it'll look like I'm typing pretty quickly, but I'm just type tab. It'll save you a carpal tunnel in the future. All right, so if I grab that percent of total calculation that we just created and I bring that in, we can immediately see that Australia is 30% of the total. You can do the eye test here and you can validate and you can verify that. We do not need total sales all countries in our visual, so we can remove it and then we get our results. There we go, right there. And so this is how we can start using Calculate to override or to change the filter context. Now I will go back. When I first started writing DAX, this function did not exist, but there is a function that's a little bit of, it's not new anymore. But what you could do is another function that many people like that is a little bit more intuitive for them is what's called remove filters. So you could have said, instead of doing it the way I did it, you could have said remove filters from country, which is effectively doing the same thing as what I did above. So you could say calculate total sales, return all countries, or you could say calculate total sales, remove filters from country, which means if there's any filters on country, remove it, which is effectively saying get total sales for all countries. And so if I hit enter, all of the numbers in my report are going to stay exactly the same as what they were before because it's doing effectively the same thing. Personally, I like all a little bit better. I like it better because it ties into other functions that you use, like all selected, all except. There's other functions that you will use, and understanding all helps, I think, with that transition. Plus, I started using all before remove filters was ever added into the DAX language. And so this right here gets us started with Calculate. Let's jump in and let's take a look at another example. So another example we might do is maybe we want to do something like compare Australia, Canada, France, Germany, United Kingdom, United States. Maybe we want to compare them to the United States. So the United States is our leader in sales. And so we want to compare all of the countries to the United States, right? And so what we can do is I can go to my fact sales table, create a new measure, and this time we're going to create total sales, and we'll call this one US for United States equals shift enter. And then again, I'm going to write out my statement of what I'm trying to accomplish here. So I'm going to say return total sales for the country United States. All right, so I'll write it out. When you start getting into more complicated ones where you got to first take a table and filter it or modify it in some way, and then you need to do an aggregation on top of it, write that out as multiple different steps. It'll help you out a lot. And then I'm going to come in here and say, okay, return. And am I changing or modifying or adding to the filter context here? And when I look at it, I realize, yes, I am. Because if the filter is country and it's Australia, I want to replace that filter on Australia with United States so I can get it side by side. Because what I want to do is get this 9.3 million. I want to see 9.3 million on this row and on this row and on this row all the way down. Because then I can do subtraction, division. I can get a difference there. If you wanted to put this in some type of, like fillable chart to see how close are all the other countries to getting to the United States where you're kind of filling it up, you got to get it on the same row, right? So yes, I'm going to be changing the filter context on country. I'm going to replace the current filter with United States. So yes, we're going to be using calculate because we are modifying filter context. So I'm going to use calculate. So return, calculate. And then for the expression, remember what I said before, when I get to the expression, I'm 99% of the time, with very rare exception, going to be using a measure I've already created. So in this situation, I'm going to do total sales. And then we get to the filter. So we see the IntelliSense right there. It says, okay, time to add a filter. And so the filter that I want to apply is going to be modifying the country. Or I'm just going to say, all right, I want to go to sales territory, and sales territory country equals United States. Now I do have to type United States correctly. It has to be spelled exactly like it obviously is in our table, but this is what I'm saying. So return, calculate, total sales, where the country equals United States, total sales territory country equals United States. So again, we can kind of write that sentence out and then dissect that statement and allow it to write and help us write our calculate statement. All right, so if I hit enter on this, and then I come over here and I go into, I want to format it, and then I add it into my table, what we want to see and what we expect to see all the way down is 9.3 million in sales. So this is perfect. This is exactly what we wanted here. We can now see Australia and how they compare to the US. If you want to get a percent difference here, you can obviously do, United States minus total sales within the filter context and then do some division. But the hard part isn't the basic math, right? The basic arithmetic is not the hard part. The hard part is, how do I get these values on the same row so now I can perform that arithmetic type operation? And this is how we do it. We use calculate to modify or change that filter context. All right, so that is our total sales for the United States. Now, there's a couple different ways we could write this as well. So we're going to write another one here. Before we jump into the next one, I do want to point out that you have this NA field. What NA does is that in our country dimension or in our sales territory dimension, there's an extra field for not applicable. So if we get a sale that happens and we don't know, for whatever reason, bad data, we don't know where that sale occurred, it would get mapped to NA. But NA has never had any sales mapped to it, which means we have good data. That's good. So by default, the way that Power BI works is Power BI will hide all of the rows that have no data. So let's say you have 10,000 customers in your customer database that are prospects that you've talked to, that you've had sales calls with, but only 1,000 of them have ever made a purchase. If you put that customer in your Power BI report and then you bring over purchases, you would only see by default the 1,000 customers that have made purchases, because by default, Power BI will automatically hide all the rows, all of those customers that have no purchases in the data model. They're still there, but it automatically hides it. So NA was there, it existed before, but we didn't see it. But because this total sales calculation says replace NA with US, with United States, we now get a value on one of our measures. So now it shows up on the report. So it's not a big deal because we would wind up using this in some kind of percentage calculation like we did before. So this row will go back away because it'll return a blank as soon as we remove that from there. But if you're really worried about it, a really easy and quick way to solve this problem is, if you were showing this and you had a bunch of rows showing up that you didn't want to show up, is you can add an if condition here and say, okay, well, if total sales is blank, then also return blank for total sales US. And so the way you do that is very simple. I'll do it real quick here. This is extra. I wasn't really going to show this part, but I'll just do it anyway. So if total sales, right? If total sales equals blank, then return blank for this measure as well. If it's not, then perform this calculation. So what that'll do is it's going to return blank for total sales US, which means the whole row is going to be blank for NA. So therefore, it will automatically hide that row again. So I'll hit enter and it goes away, right? So that's kind of one way you can handle it. Again, we wouldn't really have to worry about it because I would never put the measure total sales US in the table. I'm just putting it in the table for validation and verification purposes to make sure it works before we move to another basic arithmetic calculation, which might be this one minus that one, etc. All right, so that gives us our total sales US. I'm going to go ahead and build one more measure here before we dive into some other stuff. And so this measure is going to be total sales, and we'll call this something like, let's go with North America. I was just going to do NA like that, but we'll do North America. And so we'll say hypothetically, let's say North America is United States plus Canada, right? And so I want to return total sales. Let's close that up for the countries United States and Canada. Okay, so we want to build another measure, and we want to build a measure for total sales for the countries United States and Canada. So just like I did before, am I changing the filter context? Yes, I am. The filter context I need to change is on country. There's a filter on country that's kind of in the way of what I'm trying to do. So I want to replace whatever value is being passed in for country. I want to replace it with just United States and Canada, just like we did before. So we're going to start with calculate. So return equals calculate here. And then for our expression, it's going to be total sales. So we're going to leverage a measure we've already created. So return, calculate, total sales, total sales. And then I know the filter context I want to change is on the sales territory country. So we'll pass in sales territory and then country. And then we're going to say is in. There's a couple different ways to write this. My favorite when I have a list, and this goes back to my days of writing SQL, is the in clause. So in, and I'll pass in the little curly bracket here. And then I'm going to do United States. And then I'm going to do a comma separated list. And then I'm going to do Canada, just like that. Now there are other ways to write this. I'll show you another method here in just a moment. We'll kind of modify it, but I'll do that right there and hit enter. Now, once I hit enter, I do want to format it again. So I'm going to add in my currency. We'll go over here and choose English currency, United States. And then let's add it in. And there we go. So this is the combination of the United States. Let's make this a little smaller here so we can see it. So this is the combination of the United States and Canada. So 1.97 million, 9.3 million. That comes up to a grand total of 11.36 million. All right. So again, once we start understanding how to use calculate to modify and change filter context, it allows us to accomplish a lot of those tasks that previously would have seemed a little bit difficult. All right. Now there is another way we can write this. And so if I wanted to write this a little bit differently, what I could do, I'm going to actually comment this out, is you could use the pipe delimiters. So I could have done sales territory country equals United States. And then I could have done a double pipe delimiter where I say or, and then I do sales territory country equals Canada, right? Close that up just like that. And then let's make sure we have too many closing parentheses. So then I'll hit enter. And that's going to give me the exact same results that I got before. It's just a lot more code. So implicitly, when you do an in list, that in list is everything in the list is an or condition. So United States or Canada or whatever. So that happens automatically right here and requires just way less code. And it's a lot easier to debug and maintain, but you could type it out. There is a third method. And so if you see this, I'll just point it out very quickly here. You can explicitly use the or function. So I could do or like this. I do not use this function pretty much ever, but just in case you see it on some kind of blog or YouTube or article or something. And you can do or, and you pass in your first parameter, comma, second parameter. The or function, the and function, they only accept 2 parameters. So then you got to get into nesting them, which is very messy. I don't like it, but this will give me the same results here. So I can use that as well. But my preferred method, if I'm doing some kind of or condition, my preferred method using control / to uncomment this code, control / my preferred method is going to be to use that in clause right there. And then I just see what I want to see. All right, we're going to do one more example here. And we're going to take a look at changing that filter context again. And then we're going to pivot and we're going to talk about time intelligence calculations, year over year, year to date, rolling totals, which is really where a lot of people get pretty excited when it comes to writing DAX and how easy it is. Before we jump into that, one of the things that I do with customers all the time is we have a service called virtual mentoring. And virtual mentoring is where if you're struggling with a problem, you're struggling with a concept, you need help with a problem, you can call up one of our experts here at Pragmatic Works. We jump on a call with you and we actually help you through that problem and teach you that topic and kind of how it works as well. So it's a great service. You definitely should check it out in our description below. But to go along with that, we want to hear from you. So whether you're watching this live or catching the replay at a later date, go ahead and drop your DAX questions and your challenges in the comments of the video below. Not in the live chat, but in the comments of the video. And what we're going to be doing, and this is exciting, this is the first time we've ever done this, we're going to be picking a few of the most interesting and unique problems. And if yours is selected, you're going to actually win a free 1-hour virtual mentoring session with me. And so that's going to be one-on-one help tailored to your specific DAX needs. And you're going to get that 1-hour one-on-one session with myself. So please feel free to, and this is not a live giveaway. We're not giving this away today live in this session. This is something we're going to be monitoring in the future and looking at those comments and looking at the discussions and finding those unique problems and saying, hey, congratulations, you've won a 1-hour virtual mentoring session. So please put those comments in the chat window below. I look forward to meeting you if you win one of those 1-hour sessions and helping you out with your DAX problem. All right, with that being said, let's dive back into our next section here. And so the next one that I want to do here is going to be, what if we wanted to look at this based on year? So we've been really focused on country. How do we manipulate the filter context on country? But if I were just to change this up a little bit and I got rid of country and I bring in our year, we're going to have year 2022, 2023, 2024, 2025. And so maybe I want to create a total sales calculation for a specific year because that was our benchmark year, right? We have a benchmark year. We're trying to meet that year. That's a common theme. That's a common goal. And so what I can do is I can come into my sales table and say I want to create a new measure. And the new measure that I want to create is going to be called total sales. Total sales. And let's go with 2024, right? So 2024, that's going to be our benchmark year. And then again, I encourage you, write out what you're trying to do. So I want to return total sales for the year 2024. And so I'll come down here. And if you've been following along, you literally can just almost take your sentence of what you're trying to accomplish and use it to write your DAX expression, right? And so I know that I have to change filter context. I know that there's a filter that will either exist today or in the future on the year. And regardless of what filter is applied, I always want to return 2024. So I want to replace any filters on year with 2024. If there's no filter on year, which means it's returning all years, then I want to add a filter explicitly on 2024 and only return 2024. And so what I'll do is come in here and say, calculate. We know for the expression, we're going to use a measure that we already have. And then for the filter, we're going to pass in our date column, our year equals 2024. Just like that. That's it. So when we hit enter here and we go ahead and format that as English United States, we can add that into our table. And then we get 2024 all the way down. Again, we had no sales in 2020. We had no sales in 2021. So those were auto hidden. But if we wanted to, we could go in there and say, if total sales equals blank, then blank else perform this calculation. So we could force this value to be blank as well so that Power BI would automatically hide those rows again. There's other ways to hide those rows, but that's quite honestly usually the easiest way. But this is just another example of using Calculate to change filter context. All right, so we're going to transition now. We've done calculated columns, we've done measures, we've talked about X functions, navigation functions, row context, filter context, and we've talked about the most important function in all of DAX, which is calculate. And so we're going to continue that conversation, but we're going to continue that conversation as we dive into time intelligence calculations within the DAX language. When building time intelligence calculations in DAX, there's a couple of stipulations, a couple of requirements that we want to stick to. One, you want to have a dedicated date table. And in that date table, we want to have all possible and applicable dates that really align and match up with your fact table. So if you have sales from June of 2020 all the way through the current year, we want to make sure that your date table goes back to the first day of 2020 all the way through the end of the current year. The other thing that's very important there is that in that date table, there should only be one row per date. So January 1st of 2020 all the way through December 31st of 2025 with no duplicate values at all. One row per date. I was recently doing a full day hackathon engagement where the customer, where they bring their data, I teach them on their data, we build a proof of concept around it. And they brought their calendar table, and they are a district, a school district. And that calendar table had all of the dates for all the schools because different schools have different days for the school and get into charter and private school, et cetera. And so that table does not suffice and did not work for our calendar table. We had to build a separate table and handle that situation a little bit differently. And so what you want with your date table is one row per date and only one row per date. We also want to make sure that our date table does not have any gaps. You say, well, we don't do business in July. We're always closed in July. We don't do business on Sundays. We're always closed on Sundays. It doesn't matter. The way that some of the time intelligence functions in DAX works is it expects you to have a date table that is unfiltered, that has every possible date, a contiguous range of dates with no gaps. And so we want to have a date table with every day that matches our fact tables from the beginning to the end of the year with no gaps. Those are the requirements that will make your life a lot easier. And so that is kind of the requirements for getting started. Now, when we're talking about time intelligence functions, we're talking about things like year over year, year to date, month over month, rolling 3-month, rolling 12-month, those types of calculations. Very popular, very common, and they really give us a good idea of the company, the organization, and how we're doing over time and how we compare to last year at this time. And so those are going to be time intelligence. And when we look at the functions that are available within the DAX language for performing time series analysis or time intelligence calculations, the list is long. You have year-to-date calculations. We have same period last year. We have DateAdd. We have previous period. We have start of month, dates between, opening balance month. The list goes on and on and on. There's a lot of built-in time intelligence calculations. Now, we're not going to get to all of those in this session today. We're just going to go over a few of the quick popular ones and some of the limitations, if you will, to get you acclimated with that. But this is one of my favorite sections because when we go through this section right here, a lot of students, a lot of people new are like, wow, I can't believe how easy it was to build that calculation. And so let's jump right in. Now that we have a little bit of background, a little bit of understanding and knowledge, we're going to jump right in and we're going to start off with a year-to-date sales calculation in Power BI Desktop. All right, so the first thing that we're going to do here is we're going to create a new measure. And the measure that we're going to create is going to be total sales year to date. And we're going to use a function here called total YTD. And what Microsoft has done over the years is they've built a lot of these simplified functions that make it really easy to do these common types of actions that you would do within the DAX language. And so what total year to date does is it's going to take an expression, total sales, total cost, profit, total quantity, total transactions, and it's going to get the year-to-date total of that measure that we pass in, that expression. And so our expression, because we're doing total sales year-to-date, is going to be our total sales. Now, the next thing that this asks for here is dates. And the majority of the time when you're using time intelligence functions and you see that parameter expectation of dates, the majority of the time what that means is the date column from your date table. Now, keep in mind, we already talked about the requirements of the date table. You need to have one. That's requirement number one. We want to have all applicable dates with no gaps, right? And so we're going to pass in here the date column from our date table, close parenthesis, and that's it. We now have year-to-date sales. And if I hit enter and I add my year-to-date sales into this visualization, we have our year-to-date sales broken down by year. And if I go back over to my date table, I can grab the month and I'm going to add the month in here. So the interesting thing about this, when you're looking at the year level, the year-to-date sales at the year level, when the year is completed, is going to be the same as just your total sales within the filter context in this visual, right? Because this is total year-to-date sales for the entire year, and this is year-to-date, total sales for the entire year. The best way to see this is to add the month onto my matrix, and then I can drill down, and we can really take a look at this data. And so when we look at our year-to-date sales, we can see how it is incrementing, adding up all of the months. And so when we get all the way down to October, we see the total of July, August, September, October, which culminates into that 1.966 million. And November, we add on another 543,000. And then December, we add on another $755,000 in sales. And so we get to a grand total for the entirety of 2022 to 3.26 million. And that's what you see in December. When we get to January, this total starts over, and it starts over at 596,000. And then it also will increment, adding each additional month until we get to the end of the year. And so that is a really easy calculation that you can do. And that is the total sales year to date. Now, one of the most common questions that I get when we get to this point, very common, is, well, Mitchell, that doesn't work for us because we have a fiscal calendar. Well, I got good news for you. As long as it's not a custom calendar where it changes on a different day every year, this year it's that, this year it's that. If you say, hey, every year our last day of the fiscal year is 6/30, June 30th, or May 31st, or whatever it is, if it's always the same day, there's an optional parameter that we can pass into those time intelligence functions to make that work. And so if I go back real quick to that total sales year to date calculation, and I go to the end and I add a comma, you'll notice that there are two optional parameters that we can pass through. We're going to skip right over the filter. We're not going to add any, I think I've done maybe a YouTube video on our YouTube channel showing how to do weekdays, like total year-to-date weekdays, where I add in a filter there. But we're going to skip over that. And what we're going to do is I'm going to type on the next line here, I'm going to put in our year-end date. So you say, Mitchell, our fiscal year-end ends on June 30th. I'll say, okay. Well, I'm going to hit enter on this. And all I'm doing by passing in that fiscal end date is I'm replacing the default, which is December 31st. I'm replacing it with June 30th. So now, instead of waiting until December 31st to start over, it's going to get to June 30th and then start over. And so what you'll see, if we go back to 2022, remember we were at 3.266 million. As we go down and you get to January, it does not start over. It continues to be the cumulative total. It continues to add up. And you'll see that all the way until we get to June. And once we get to June, it then starts over in July. Now, if you're working with a fiscal calendar, you should have a fiscal month and like month number and a fiscal year in your date table, which we actually do. And so if I were to come over here and just very quickly duplicate this, so I'll do this very quickly so we can get to some other DAX calculations. If I come over to my date table and I get rid of the year and I replace that with fiscal year, this is going to make a lot more sense. And so now when I'm looking at 2023, and if you look over here, this one's going to look very confusing because of the whole fiscal year thing. But when you look at it here with the fiscal year, 2023 is from July all the way to June. And if I expand down, you'll see we have January, February, March, April, May, June, July, August, September. Now, these are oddly sorted because, again, we would want to have a fiscal, do I have a fiscal month here? Let's see, fiscal quarter. Where is it at? I do not have a fiscal month number. I might have deleted it. But you'd want to have a fiscal month number. So that would be like July would be 1. And then all the way down. And so then you would sort this by your fiscal month number, so it would sort correctly, or you'd even have a fiscal month that would be exactly the same as your original, but sorted by fiscal month number, so it would sort correctly here. But this is how you would show off your fiscal year if you're dealing with a fiscal calendar, and you'll see the fiscal year-to-date totals are correct, and that's exactly what we're looking for. All right, so I'll delete this one, remove it. I'll come over here, go to my total sales year-to-date measure. So let me open that one back up real quick right there. And then I'll get rid of this optional parameter. All right, so year-to-date is a very popular one. You also have functions in there for total quarter-to-date. So if you're like January through March 31st, trying to get just the running total for that quarter, you can use that. There's also a total month-to-date. So if you're looking at like June 15th or June 13th, and you want to be able to compare June 13th to the prior month, month to date, then you might get that and just look at that and be able to look at that comparison. How are we doing this month compared to last month this time? You could do a prior month calculation. And so that's going to be that right there. Now, the next thing that I'm going to talk about, and this is a huge one, very important, is prior year. So I'm going to get rid of that right there, and we'll go over to our fact sales. We're going to build a new measure, and this is going to be our total sales prior year. Prior year equals. Now, what I'll do here is I'm going to say return, okay, total sales for the prior year, okay? That's the beginning. I'm kind of commenting out, putting in the notes. Here's what I want to accomplish in this DAX calculation. And then I'm going to come in and do calculate total sales, right? So just kind of dissecting that sentence, return, calculate total sales, and then we get to the filter. Now, there's a couple different ways to get prior year, or a couple different ways to write this. I would not recommend using the previous year function. It fundamentally will look like it's working, but it's a little bit different. I won't get into the details of that right now. So the measures that I prefer, the functions I prefer, is either same period last year or DateAdd. DateAdd I actually prefer because same period last year comes from DateAdd. It is derived. It's one of those simplified functions that DAX created, or Microsoft created. So same period last year actually comes from DateAdd and does exactly the same thing. But DateAdd, if you get used to the syntax, gives you more flexibility. And so what I can do here is say, okay, DateAdd, look at the first parameter, dates. Remember we talked about earlier, anytime you see dates, you pretty much want to use the date column from your date table most of the time. So date, there we go. Number of intervals. Well, we want to go back to 1 year, minus 1 year. Now you'll notice as I go through this, I could have done -2, -3, -4, but also I could go back 1 month. So if I want to look at total sales for last month and compare last month to this month, I could do that. If I want to look at total sales for 1 quarter ago, I can do that. Total sales minus 1 month. So I'm going to do a year, and then we're going to do this right here and hit enter, and then we will do that. I am going to format this one. I forgot one formatting so far. I'm going to do that, and then we'll add it in right there. And what you'll see is perfectly is giving me what I want, 3.2. So if I'm looking at 2023, I get total sales for 2023 of 6.5 million. And then I can see that the sales were 3.2. Now, the cool thing about this is that DateAdd is very dynamic. This is how it's different than parallel period or previous year. It will work at every level in the hierarchy. So when I go down to the month and I come down here and I look at August, I can see August of this year that I'm looking at, 2023, is 546,000. The prior year of August for 2022 is 506. So when I drill down in my hierarchy, I actually see the prior year for the month that I'm in, for the context that I'm in. If I were at the quarter level, I'd be able to see that quarter 1 year ago. And so it's a very dynamic measure that works at each of the different levels, not week. Week is its own thing. If you wanted to do week, you would have to have in your date table the week number, and you'd use calculate, but you wouldn't use this time intelligence function. You'd build it slightly different, not hard, but you would build it slightly different there. But for your day, for your month, for your quarter, for your year, it's going to work at every level of that hierarchy. And so that is a really cool thing. Now, the other thing I want to tell you that's very, very important is that when you're working with DAX, you're going to see these patterns that emerge, that are repeatable. You can use them again and again and again. So for example, if I came to you and I said, hey, I love that report, that year to date is phenomenal. But on that line chart with that year to date where I'm seeing it grow, you know what would be amazing? It would be amazing. So like, for example, let's say I had something, see if we could do this quickly here. If I had a line chart here, right? And on this line chart, we had something like year-to-date sales. So we have year-to-date sales on this line chart, and then we break this down to the x-axis. We're going to add year on there, and then we're actually going to add, we might even do month year. So if I were to do month, and I don't think I sorted month year, so that's very unfortunate. Let's do month number of year. So we'll do month number of year, and then I'm actually going to filter this down just real quick. So I'm going to filter this visual down to just, so you can see this, 2023. So we'll go with 2023. All right. So this is showing 1 through 12, 2023, very simple report. So we have this is total year to date. And I come to you and I'm like, you know what would be awesome here? I want to have another line on this chart, another line that shows total year to date sales and shows prior year to date sales. I'm going to see, are we doing better this year than last year? Are we doing better? And so how would you create that? And a lot of people get tripped up right now. They get tripped up. However, remember we just talked about the fact that prior year is a pattern you can use again and again and again. And so if I go over here and show you the prior year calculation, all I have to do year to date, prior year, is replace total sales with year to date sales. Calculate. So I'd build a new measure, right? Let's do it. We're going to build this measure. We're going to build total sales year to date, prior year. Okay. So we'll go over here. And this is why I say it's really important as these calculations start to feel and seem more involved, really important to kind of type out what you're trying to do. So we'll do total sales year to date, prior year equals. Then I'm going to type it out. What am I trying to do? Return year to date sales, right? For the prior year. Okay, well, return, let's calculate. This is where a lot of people get confused on this one. They're not sure what to put in the expression. But if I follow my sentence, I'm just going to put year to date sales, right? So year to date sales. And then I'm going to go and I'm going to do DateAdd. Again, you could use same period last year, a little simpler if you want. Dates minus 1 year. Close parenthesis, close parenthesis. That's it. So now I come to you and I ask you for that calculation for year to date, prior year. I'm going to go ahead and format that. We'll take it, if we can find it real quick, we'll drop it in our line chart. And now we can see how are we doing this year versus prior year. Now let's change it to 2024. So if we go to 2024, you can see current year is in blue, prior year is in black. And so all the way up until June, prior year was doing better. But then coming up on the end of the year, the current year exceeds and goes beyond that. Such a beautiful, elegant solution. Prior year, somebody comes to you and says, hey, I want to see prior year. Say, no problem. Calculate whatever the measure is, profit, transactions, year to date, whatever it is, DateAdd minus 1 year. Or you could do same period last year. The benefit of DateAdd is that you can change the parameters very easily. You can go back 2 years. I know customers that back around 2020, the metrics they were comparing against weren't that great. They wanted to go back 2 years, so they did that. But you could also say, hey, I just want to look at, you know what I want to see? I want to see total sales year to date for the prior month. So then I would come in here and just do month. And that would show me the prior month as well. Super cool that we have these DAX patterns that emerge that we're going to be able to leverage. So we're going to do one more here. We're going to do month over month, right? We're going to do month over month, and we'll take a look at what that looks like. So if I come over here and I am going to go ahead and grab my fact sales, I'll do a new measure and we'll stick with total sales because we've been in total sales the entire time here. And we're going to go with total sales and we'll do, prior month equals, and then we're going to do our statement, right? So return total sales for the prior month. Then I go down here and I'm going to do calculate because we know we have to change filter context, right? We have to take the current month and go back 1 month. So we are changing the filter that's being applied. We're going to grab total sales all the way at the bottom. And then we're going to go back, DateAdd, right? Date column from my date table. And then we're going to go back -1 month right there. All right, we'll hit enter. And now we have prior month. Now I am going to delete this chart down here. Go ahead and pull this down. And then we will expand this and let's get rid of prior year. All right, so we have this measure, and I did that very quickly because I know I'm at the end of my time here. I'll pull that back up, calculate total sales, DateAdd -1 month. So I have this measure that goes back 1 month. So if I'm looking at August, I'd expect to see 473 next to it. September, I'd expect to see 473 minus 506. And so what I could do is pull this in, and now I see it next to each other right here. And if I look at it, I can look at September 473, 506, and I can verify that 506 is the prior month. So that prior month calculation is working. Now, normally what we want to do is we want to get maybe a month over month difference. Like we want to get the growth difference. Like, so we could do like total sales, MOM difference, right? Or MOM growth. So let's build one final measure. Then I'm going to show you how to organize these measures. And then we will hand this off to Greg. So if I come back up here to the top and do fact sales, I can say I want to build a new measure. And the new measure I want to create is going to be called total sales month over month growth. And if you want to add percent on the end, just so it does that, we can. And so total sales month over month is going to be, let's start with divide. So we know we're going to have to divide. We're going to take this month, so total sales, we just type it out. Total sales minus last month. So we already have that. Total sales prior month, comma, and we're going to divide the difference of that by the prior month. So we'll go with prior month. I just typed PM because I knew it would work. And so I'm going to take total sales minus the total sales prior month, whatever that difference is. So right here, it would be 506 minus 473, giving me somewhere in the range of 32,800, right? 32,000. And then I would take the 32,000 and divide it by the prior year to get the percentage growth. So that if it's positive, we're going in the right direction. If it's negative, we're not so much. And so we'll hit enter on that, and then we'll go ahead and format that as a percentage. So we'll grab that, pull that in, and then we can see the difference. So for example, right here, 506 minus 473 is going to give us somewhere in that 32,000 range, I think. 32,000 divided by 473 means we had a 6.93% growth, almost 7% month over month growth. We had a little bit of a fallback here, but then 8%, 5%, etc. The growth calculations and ratios and percent of totals, they're basic for the most part. It's basic arithmetic, right? It's this minus that, this divided by that. The hard part when it comes to DAX is understanding how do I get the thing that I'm going to divide by, right? How do I get the total sales for all countries, the total sales for the prior month? Those types of calculations is where we end up using calculate to get that denominator so we can do the division or for other reasons. Now, the last thing I want to show you is how do we organize our measures? And so if I go over to my fact table, you'll notice this is a mess. It's a mess of measures. Some people use calculated tables or a measures table. I have no problem with that. That's an old school thing that we did for many years because we didn't have folders. And I'm still okay with that if you use it. There's some good arguments for it. I typically, in Power BI Desktop, I typically use folders. And the way I do it is if I go over to my model view, I can go over to your table. And so if I go over to like my fact sales table here, I can grab all of my columns in here, right? And so really, I'm just going to multi-select. Let me multi-select all of my columns. I'm going to uncheck profit margin. I'm going to grab total product cost, unit price, and that. So I'm multi-selecting using a combination of Shift and Control. And I'm going to take all of those columns and I'm going to put them into a folder called columns. So I'll do that first. So now all of my columns are now in their own folder. If I need any columns for whatever reason, I can go grab them. Then if you want, you can grab your measures and you could put your measures in their own folder or folders. So for example, if I wanted to grab all of my time intelligence calculations, I could come in and grab those. And then I could come over here and put them in a folder called time intelligence and hit enter. And then you could go down the list. Let me close that and close that. And then you could go and grab these other ones and either put them in their own folder, or if you choose, you could just leave them in the root of the table. But you can use these folders right here in the model view to select your, like if I wanted to grab all my base measures. So all of these right here are base measures. Oh, we missed temperature key. That should be in columns. We could grab all of those base measures right there. I could put those in called base measures. All right. And so you can organize these so that when you're in your report view, you're working with different teams, they come in here, everything is in its own folder, a lot easier to work with, a lot easier to find the things you need. There is one last thing that I want to cover here. One of the questions that we get all the time is, especially when people start getting into data modeling in DAX, is, Mitchell, is it okay to have multiple fact tables in my data model? The answer is absolutely yes. But then the question is, well, if I have multiple measures in my data model, how does that affect my DAX calculations and other things? And the answer to that question is it does not really affect your DAX calculations if you have a good data model. And so over on my report view, I have a sales table and I have a returns table. You'll notice that these tables have some shared dimensions. So if I'm filtering my sales table by date, I can also filter my fact returns by date. And so if I wanted to show this very briefly here, I'm going to get rid of the total, well, no, let's keep total sales. I'm going to get rid of prior month and month over month growth. So right now we have our total sales for every month for every year. And if I wanted to also be able to see my returns for every month, every year, to see them side by side, to find out a percentage, what I can do is go over to my returns table and I can bring in the return amount and really just drop that in. So I'm not going to create a calculated measure for this one so we can quickly see it. I'm just going to let it auto sum here. And so you'll notice right here that it's doing a summarization of that. And then right here, I can now see that for July of 2022, we had $473,000 in total sales, but we had $14,000 in sales that were returned. Now, July or August gets a lot worse. We go from 14 to 29. We almost double, but our sales didn't double. And so this is where we can start doing some further analysis. And the cool thing about this is that if I wanted to do a percent, all you do is take the return amount and divide it by total sales. So that's a very quick calculation. But another one, and maybe more important to you, is, well, what if we want to look at this by product? So I can come over here and look at product, and I'll grab the product name, drop that on the rows, and now I can see the return amount for all of the different products. If we wanted to take this a step further, we could look at this by specific transactions, right? So this is when it comes to building in multiple fact tables in your data model in DAX, the biggest thing is having your dimension tables or your descriptive tables that can drill across multiple fact tables, because then all I have to do in my fact returns is create my return amount, my total return amount, and in my sales, I have my total sales amount. I filter them both by date and it works. I filter them both by product and it works. So I just wanted to briefly show that in this session. We talk about this a little bit more involved in the data modeling workshop that we did on our YouTube, so make sure to go check that out. Now, I hope you learned a lot from this section here. Now we want to show you a relatively new feature in the last few years here that's been introduced into Power BI, and that is visual calculations. And so I'm going to hand it over to Greg Tresiak, who's on our team here at Pragmatic Works. I'm sure you've seen him on our YouTube before, and he's going to do this next section for us. So thank you guys, and you'll be in good hands with Greg.
All right, thanks, Mitchell. What's up, everybody? Greg Tresiak here, one of the trainers at Pragmatic Works and the author of our visual calculations class here on the On-Demand Learning. Now, I'm going to show you some visual calculation concepts that I think are really going to be a game changer. One of the things that Mitchell has introduced is the concept of sometimes we're going to have scenarios that are common business problems that DAX might struggle with. I know we know that from all of our virtual mentoring sessions. A lot of times customers might say, hey, I want to try this. And I start scratching my head and going, well, you might not like the performance of what we're going to have to do. So visual calculations is something that really is going to kind of bend DAX a little bit to achieve some of those much more difficult results. Visual calculations are really designed with the end user in mind, and they are attached to a visualization. Because they're attached to a visualization, it becomes ultimately easier to create these. The only issue you might have is that they are restricted to that current visualization that you have them built in. Now, let's dive right in, because what Mitchell has left us with is a table here with product, our total sales, and return amount. I could, if I wanted to start calculating some more things like profit, etc., continue to make those explicit measures, the ones that we create that have that calculator symbol. But rather than doing that, we're going to go ahead and look for visual calculations. Now, you're going to make sure that you have a more up-to-date version of Power BI. Visual calculations have been around for quite a few months now, and you need to at least make sure you are somewhat up to date. How to check really quickly is on your visualization, all you need to do is select the visual, go to your 3 ellipses, the more options button, select that, and then right at the bottom here, you'll see a new visual calculation. That is one of the quick and easy ways to find it. You'll also, however, find it up in the top ribbon here under calculations. I've got new visual calculations, and easily I can grab those. So make sure you select that visual, and that's going to be available to you. If you don't see that, you need to update your Power BI desktop. No ifs, ands, or buts. Now, what we have here is pretty good. We can do a lot of visual calculations, but I want to up our game a little bit here. So what I'm going to do is I'm going to take what we have right now, and I'm actually going to duplicate the page. So I'm going to go over to this plus sign here. Right next to it, I'll go to page 1, right click, and then I'm going to duplicate. If I wanted to, I could have made a new page and continued that way, but we're going to go with the duplicate of page 1, and I'm going to rename it to my Viz Calcs. Now, to show you some of the best features of visual calculations, I think it's much better that we change this visual away from product and adjust this to have some more time intelligence, some more time series. I think visual calcs will make a little bit more sense this way. So I'm going to take out product here, and then I'm going to go ahead and replace to our rows something from our date column. So let's go over to the date column, and I'm going to bring in year. We'll also bring in our month. I can bring that in right below, starting to build our hierarchy on the fly. And the last thing I want to bring in is week number of year. I think that's a really cool one to see here, because that one is going to allow us to see things at the week level. Now, right now, I can move up and down the hierarchy using my navigator buttons over here. I can go down and see the month level, and I can follow it up with what was the actual week number associated here. Pretty nice. But what about something like a running sum? Now, there's definitely ways we could write that out in DAX and do all various calculations with those functions and do some time intelligence. But visual calculations also are pretty nifty. I'm going to go ahead to my 3 ellipses and go right over to new visual calculation. Here you'll see some templates that are ready to go for you. You'll also see the option of custom, which would be a blank one. Remember, visual calculations are designed to make DAX a little bit easier, especially some of the things that are quite hard to do. I'm going to start us off here by just selecting the template running sum. I'll select running sum, And now it's going to say, hey, you're using a template, by the way. It's also going to allow me to edit the formula bar here. This is where I'll modify the calculation to make sense for what I want to do. Now, pro tip here, that's a little small to see. So if I hold Control on my keyboard with this selected and do the plus or minus sign, or even if I need to, just spin my mouse wheel, I can make that a little bit larger or smaller for me to see. Now, running sum seems kind of like a unique function, and you may be used to DAX and not truly used to some of the things in visual calculations. It kind of has its own language, own little library. What we're going to do here is we're going to replace field here with something from the visual. And you'll notice something right out of the gate. I have one square parentheses, and all of my options are limited to fields that are inside of the visual. That's one of the things about visual calculations that's very nice, but also could be a little bit frustrating. Here, I only have the option of month, return amount, total sales, week number of year, and year. That's it. So all of the categories I've placed into it are what I can pull from. Simple. Now, we want a running sum of the total sales. So it's going to highlight total sales, and now I can simply hit enter or the plus sign here to commit the visual calculation. I'll go ahead and press that, and there we go. There is a running sum of total sales just like that. At the year level, I can see that everything matches up. 3.2 million, 3.2 million, and now we should see the next level here be 3.2 million plus 6.5 million, which is about 9.79. Perfect. Chef's kiss. I love it. It looks good. Now, running sum is nice here, and I could continue down the hierarchy and see this working throughout the various levels. Now, this is good, and I ultimately end up with that 29 million. As you can start to see with total sales, we continually add on here. But not always am I just going to want this full-on running sum. A lot of what we might do in Time Intelligence's DAX is I want to reference the last 3 months or the most closely related item or something along those lines. Well, no need to fear, because instead of writing some elongated DAX to achieve some of those and play with filter context, instead, we're going to keep leveraging visual calculations. The next one I want to show you here is something pretty cool. This one is still going to use running sum, but I'm going to show you some of the hidden secrets that will allow you to unlock a bit more. Let's go ahead and create a new calculation here simply by selecting the formula bar. I'm going to call this my running sum HP. And I know what you're wondering. Does that stand for health points? Okay, I know. That's the nerd in me coming out. This is going to revolve around an extra function called highest parent. Let me show you how this would work. I could continue to use the running sum template here if I wanted to. I'm still doing a running sum of my total sales. But instead of this continuous number going over and over and over again, I'm going to, instead of closing the parentheses, use that comma. Here you'll see that there's more than meets the eye to running sum. It calculates the running sum here along the specified axis of the visual data grid. Now, what's my axis? What are blanks? What are resets? All right, those can be pretty nifty. Definitely check out our on-demand learning. I want to showcase one for you today, which is reset. What we'll do is we'll add in 2 more commas to be centered around the reset. We want the running sum to reset when we get to a certain value. You could decide to go 1 and let it reset, 2 and a certain number, but we have a function here that will really help us out called highest parent. All right, we got to think about our family tree. Our parents, they're right above us. We're here because of them. We revolve around that extra level, right? Just like when we have year and month together, we might have the highest parent be the changing of a new year, of a new week, of a new month. Depends on your level of granularity. I'm going to leverage highest parent here and close the parentheses. And I want you to see the magic at play here. I'll hit enter, and now I have this new running sum HP. At first glance here in 2022, hello, Earth to Greg, nothing's going on, bro. But bear with me, scroll down a little bit lower, and you're going to start to see that when the highest parent is achieved, that changing of the year, in this case, we revert back to the initial total sales, and the running sum begins again. All right, now I know if you're a little DAX savvy, you know how to do that before, but this is a pretty awesome thing. The question becomes, how can we keep playing with this functionality? Well, if you want to test it out a little bit more, you can use something like previous. Previous is another sample function that we can leverage here. Go ahead and make a new template with your versus previous. This is going to have similar functionality to what we just saw with highest parent. I'll select versus previous here, and now I've got two things to go with. We're going to play with this in a moment, but what I would like you to try is let's go ahead and rename the template previous, and I want you to get rid of everything before the function. We're left with just previous in a field. Watch this. Let's keep running with total sales here. And I want to know the previous total sales. Well, as I hit enter, you can see a little bit of how we're returning this. In fact, what I'm going to do is move this right next to total sales just to show everybody a little bit neater. You'll notice here that previous is pulling total sales, but it's one below. It's pulling its previous in that context. So we can see this staircase pattern, 473, 506, and again, and through on, and through on. It's staggered like that because it's returning the previous value. Okay. Let's think about one of the most common questions we get in virtual mentoring when it comes to DAX and calculations. Hey, Greg, I know how to do XYZ in Excel where I can pull from this row and move it down and do some things like this, but Power BI is having a bit more trouble with it. How can we go about it? Well, there's definitely some ways that we can tackle it with some virtual tables and some cool craziness, but much better would be pulling a visual calc, pulling previous and running calculations from there. That's where we can now graduate into versus previous. So let's grab a new expression. We'll actually pull versus previous, and this time we are actually going to build it out totally. Let's go ahead and we'll say total sales for the field, and we'll subtract the previous total sales. My DAXperts out there, you're probably getting into what I'm thinking about here, what we're going to do with this. Let's go ahead and hit enter, and let's see what total sales minus previous is. A very complicated thing to do in a DAX explicit measure, but literally 2 quick steps in a template, and you're going to have great success. Well, let's look at this versus previous. All right, so total sales, it matches up well. And then we see that 473 to 506, okay, that's about 32,000. Here we go. We go back to 473 minus 32,000. Sign me up. I mean, this is such an easy way. And so many times I show this to people in our virtual mentoring services and they go, oh my gosh, I've been sitting on this problem for a week. And you just did it instantly. Like, what? Again, downside here is it's tied to this visual, but trust me, this is definitely a way to go to solve a very common business solution problem. Okay, I love it. I want to show you a little bit more. And then I'm going to send you back over to Mitchell. And I, again, want to remind you about our on-demand learning course on visual calculations and remind you, spend some time with us in a boot camp, in virtual mentoring. We talk about all these various things that ultimately are going to save you a lot more time. And as we know, time is money in this day and age. Okay, so what else we've got here? Versus previous, I really like that. Where I could continue with this, if we really just want to push the limit for a moment here, is let's get this into a percentage, right? What is that percentage change from the previous? For this, you're sticking around with me. I'm going to put the icing on the cake here. Let's do a custom here. We'll make our own. And I'm going to call this my VP percent, my versus previous percent. Now, here is where things get a little bit weird, right? Formatting here is tough because if I try to format by clicking on the visual, like visual calc here, not really going to show me any formatting like a traditional measure. So what I have to do instead here is embed the format function into my calculations. Let me show you this here. We're going to use format, and that will allow us to convert a value to a specified format. We're then going to use divide because we're going to need to divide the total sales minus the previous total sales. And in this case, the previous function, total sales. We'll close that up, comma. Our denominator here will be the previous total sales we'll close that up, and now we're back to format. How we want this formatted is a percentage. So very easy, do a double quote, write percent within your double quotes, and close it up. That's all you got to do. It's going to turn this thing into a percent. So again, we're dividing the total sales minus the previous total sales. So we're getting the versus previous into the previous total sales. So what was actually the change here? And there we go. What was the increase? What was the decrease? We went up, we went down. Right here, I'm kind of looking at the week number level. But let's go back over here and take a peek. How have we changed over time? This is just some more examples of the flexibility you're going to have when you are working with some awesome visual calculations. All right. If you've seen a lot of my videos, you know I'm a big fan of emojis. So I got to throw you something with emojis, a little bit of that icing on the cake, just so you have something to really kind of enjoy. And it uses the format function just a little bit more here. I'm also going to take a moment, clean things up a little bit. I'm going to go ahead and just remove one or two of these just for now. You know what? Actually, we'll leave it over there. That's okay. We'll leave it over there. I'll make one more visual calculation here, and we are going to go ahead and get our percent return with emoji. Oh yeah, you got to have emojis. It's 2025, people. We got to. And we're going to format our, let's go with our, let's go ahead and format our versus previous. We'll go ahead and format our versus previous. And how we're going to format this is, let's see. How do I want to go about this? Let's say that we want to, you know what? Do we really need to change it up too much? Let's actually leave it as is. And let's bring it in with an if statement. We'll say if, I don't think we'll actually need to format too much here. If versus previous is, let's go greater than or equal to 0, or actually less than or equal to 0, then we want a nice red emoji. And I've actually got one right here. I'm going to copy this out. You could really put whatever you'd like here. We're going to place that in some double quotes. Great thing. You can just throw emojis in here. And else, we're just going to do a blank right then and there. So versus previous, if it is for there, you're going to bring that in. And let's see. We'll bring that through. Now we've got our emojis denoting that it is in the negative. I might change this up, just have a little bit more fun with it. And let's go ahead and bring in our versus previous. And the emoji. We'll just do a simple concatenation with the ampersand there. And there we go. A little bit of formatting we definitely can add in, but if we have a negative, we've got some conditional formatting there. Nice and easy, built into Visual Calcs. Hopefully this answers some really cool solutions for you, gives you a little bit of fun, something more to play with. Definitely join me on the on-demand learning where we can check out more of these cool things. I am going to hand this back over to Mitchell. Thanks everybody for hanging out and looking at visual calculations. This has been Greg Tresiak. Happy DAXing and enjoy the rest of the Learn with the Nerds.
All right, now that you've learned about visual calculations and we've already talked about the fundamentals of DAX and a lot of the things that we can do with that, we're going to be diving into two other additional topics here at the end. One which I think is probably the most exciting part of this entire presentation, which is going to be talking about Copilot in DAX. However, before we jump into Copilot in DAX, I want to take a look at the DAX query view, because this is actually where we're going to be doing Copilot in DAX, but also where a lot of other cool functionality and capabilities have been built into the tool. Now, due to time, we're not going to do a deep dive and spend an hour inside of the DAX query view, although we could, but I've already done some videos on our YouTube channel that talks about the DAX query view and some of the different capabilities. So please take a moment after this session, go take a look at that video. But the DAX query view was introduced relatively not too long ago, maybe about a year ago in the Power BI desktop tool. So in the world of Power BI desktop, it's relatively new and it has a lot of really amazing and cool capabilities. So for example, one of the biggest problems that I see a lot of times with customers that are working in DAX and Power BI is we have a DAX measure and we want to modify that measure, but we don't want to modify the original measure. So I get customers that come to me and they have 10 versions of a measure because they keep copying the measure and they keep, changing it a little bit. And then when they get to the end, quite frankly, they're afraid to delete any of them because they don't know where they're being used or which one's the one that they wind up keeping at the end. And if you're watching this today, put it in the comments live. I bet that you have come across this problem as well. And so the DAX query view gives us a way to actually modify and test our DAX calculations without saving those changes until we verify and validate that that's exactly what we want. The other thing you can do in DAX query view, which I think is actually my favorite feature, is being able to go in there and see the lineage of a measure. So when I'm working with customers, I'm doing a virtual mentoring session and we're trying to figure out why something's not working the way they think it should, I have to start going through this scientific method of, okay, let's start from the last one and go to the prior measure and go to the prior measure, because all of these measures are built on top of one another. So one of the coolest features here is if we go over here to the left and I click on DAX query view, one of the coolest features in the DAX query view is being able to see the definition of the measures and then see the definition of the measures along with all of the other dependencies. So for example, if I go over here and I look at my fact sales table, we have a few measures that have been built on top of other measures. And so if I were debugging, for example, let's say profit margin, I know that profit margin is my total sales or my profit divided by my total sales, right? And so those are measures that have already been created. So inside of my profit margin calculation, I am using other measures, which might in turn be using other measures. And so in order to get a holistic view and to see the entire lineage of where this began and how it got to where I'm at, What we can do in the DAX query view, which is really cool, is I can come over to the profit margin, click on the ellipsis here, and then I can tell it quick queries. And under quick queries, we got a few options. So explore all of these options and really get to know them. But what I can do is come in here and say, hey, I want to define with references and evaluate. Now, if I just wanted to look at only this measure by itself, I would just say, hey, define it and evaluate it. But that's not what I want to do. I actually want to define this measure and I want to define all the references for this measure. So I'm going to go ahead and click on that option right there. And you'll notice when you look at this on line 2, I have total sales. So this says, hey, there's a total sales measure, which is the sum of sales amount. And then on line 5, I have total cost. On line 6, I have profit, which is sales minus cost. And then on line 7, I have profit margin, which is total profit minus total sales. And all of these measures are the measures that were used inside of that profit margin, and they are defined here. So now you can see at the bottom that this has already been run and executed, and we get kind of the holistic view of this. There's no filters that have been applied. So we have 29 million in sales, 17 million in cost, 12 million in profit, etc. Now, if I were to look at this and maybe I build this out a little bit more of my evaluate, so I'm looking at this by product or by year. But if I look at this and I say, oh, those numbers look to be a little bit off, let me try something. This is where a lot of customers would go in here, copy a measure, build another version of it, and make some changes. But what I could actually do here is I could come in here and say, you know what? When I'm looking at my sum of sales, so we'll go all the way back up to sales, if there was some cost that I'm supposed to subtract from this, like a value-added tax that was included but shouldn't be there, so I need to subtract it out, or some kind of basic thing I need to change, what I could do is I could come in here and say minus, and then I could minus whatever that thing is. And so I might even do something like times 0.9. So let's just do times 0.9 so you can see that it changes. Now, I've changed the measure technically, but I haven't updated the model. So what's really amazing about this is I can come up here to the top and click run, and I can see what kind of impact that change is going to have to my table at the bottom, my result, without changing it at all, right? So without saving it to the model. So I'm going to go ahead and click run. We see we're at 29,358,000. We click run, and all of a sudden we're down to 26 million. That did not affect our total cost, but it did affect our total profit, and it did affect our profit margin. Now, if that's what we've determined was the final result, and that's what was missing, then I can say, this is beautiful. Those numbers match up exactly back to the Excel file or our other reports that we're trying to tie this out to. This is amazing. I'm going to come up here to the top. I'm going to click update model with changes, and boom, that is going to work. That's going to change it. It's going to update that measure in place. If I were to hit update measure, I'm not going to do that. I don't want to impact it, but that's it. Now I could say, you know what, I'm done. I actually, I don't want to save it. So I come down to the bottom, I close out the query, and I don't save that change. But this is, for me, as somebody who works with customers with very complex models, very complex scenarios, and we jump on a call, I'm only got an hour to try to figure out what's going on and what their problem is and how to solve it. This is going to be a lot of help for myself and my customers. And every time I show this to a customer on a call, they're like, oh, I didn't even know this existed, but this is a really amazing capability. So check out the DAX query view, a lot of really cool capability that exists. And finally, it is time for us to dive into Copilot. AI and this conversation around AI has taken over everything that we do in our daily conversations, in our daily jobs. We're hearing about it everywhere. And the question that we're getting now is, hey, can I use Copilot to write DAX? And the answer is unequivocally, without a doubt, absolutely, yes, you can. And it is pretty good. Now, there are some gotchas and there are some concerns and there are some things to watch out for. And I'm going to talk about that here at the very end of this session. But first, I want to highlight what's really, really cool about Copilot and what you can do and how you can leverage it. Before we get into that section, it's important to understand that when you're working with Copilot, you do have to tie your Power BI report, your PBIX file to a workspace that has a fabric SKU. And this can be as low as an F2 SKU, which is less than $1 per hour. It's very cheap. But you do have to be pointing to a fabric SKU to use Copilot inside of Power BI Desktop, which is exactly what I'm going to be doing right here. I think that using the Copilot using Copilot, not the Copilot, using Copilot inside of Power BI Desktop is the best place to be using it because it's directly tied in and connected to your model, to the relationships, to all of the columns. And so it's going to be able to give you better results than if you were to go out to some, AI that's outside of your model and say, hey, build me a measure or something that does this. And so it is going to work better here than if you were to take it somewhere else. Now, this does not work with a Fabric trial capacity. So if you're working in Fabric, if you're in the Fabric service and you have a trial capacity currently, Copilot does not work with that. You do have to have a paid SKU, and it can be any level of SKU. This was something that was announced at FabricCon. They said, hey, Copilot is now going to work with any SKU. So no longer just F64, which is very expensive. But if you have an F2 SKU, you're just building out demos, testing, building a proof of concept, that will work as well. And it is amazing and it is awesome. So let's jump right in and figure out how we can leverage Copilot and just take a look at what it can do. Now, I will tell you, I hope that it gives me what I'm looking for here, but there have been times where I put in similar prompts, I assume, and I get different results. And there have been times where I do get incorrect results. But we're going to test this out. We're going to do it more or less live on this recording, and we'll see what happens. So I'm going to go ahead and open up a new query across the bottom here, and I'm going to hit Control I, and you'll see it on the top. It says, hey, select an icon, Control I, and I'm going to hit Control I. And now it shows you that you can do a couple of things. You can suggest measures. You can ask it to suggest measures based on your model, which is amazing, based on the Tyndall view, just the structure of your model. You can ask it to explain a DAX topic. I'm going to come back to that one in a minute because that one is amazing. And then you can ask it just to write DAX queries. And I imagine that most people are going to be using it for this. So what I'm going to do with this section right here is I'm going to say, I want you to build me a measure. So let's just start with something basic. Create a measure that returns the prior week sales. Now you saw this with Greg in the visual calculation section where we showed a really cool capability that exists there. But now let's see how Copilot does this. So I'm going to go ahead and hit enter. I'm just telling it, create a measure that returns this. Usually when we run Copilot, it's going to take a few moments. And it's going to go through, looking through the model, thinking about the calculation that it needs to perform. And so this is a question I get all the time. How would I get the prior week sales when I'm looking at this calculation? And so it's built a measure here. You'll see it's built on line 5, a measure called prior week sales. It's going to calculate the total sales, and it's going to take wherever we're at in our filter context, and it's going to go back 1 week. Now this would be an example, and I didn't know what it was going to give me here. This is actually an example of one that I don't really like that much. I don't like that it's doing -7 because this would say at the month level, go back 7 days. I would prefer that it actually leverage the week number of year or week number field that's in my date table and go back -1 on the week number. So define what current week number is, go back 1 week number. That's how I would manually build this. I actually don't like this. I think if I'm at the year level, the quarter level, the month level, I would want it to not do this query. I'd rather it return blank, but only return a result at the week level. And so I don't love the way that this one turned out. Now this comes down to prompt engineering. We would want to write this a couple of different ways. And every time I write this calculation, I always get a little bit different result. But I could have been more specific, week sales, and I could have said something like using the week field from the date table and only return results if the filter is at the week level. Now, this is the first time I'm ever writing this like this. I'm just adding some additional context. I'm saying, hey, I don't really like the way it is, so let me try it again, and then I'm going to hit send. And once I hit that send, it's going to spend a little bit more time, and it's going to go through that DAX calculation again, and it's going to change it. It's going to modify it. So let's see what it does here. So it's saying it's going to create prior week sales. It says if there is only 1 week number of year, meaning there's only one in the filter context, so I'd have to be at either the day level or the week level to get that, then go back 7 days, else blank. So this is actually a lot better. I like what it did here. I like what the prompt did. It's still not the way that I would have personally written it, but it's actually a lot better. And so what we can do is you'll notice that if I want to keep the query, if I'm happy with the query the way it is, I'm happy with the naming of the query, which is fine, I can actually come over here and say keep query. And once I keep the query, I can then come up to the top and say update the model with changes. It does not save the measure until I update the model. It has not been saved. So I'm going to say update the model with my changes. There's no way to undo it. You'd have to go in there and remove it. And then I can actually run it to see what the results are going to be. Now we have no context in this DAX query view that's going to say, hey, here's the current week, go back. And because we're not at the week level, we're at the total level for the entire model, which is all weeks. So it clearly has more than one value. It's going to return blank. So at least we know that part of the equation is working. But if I want to validate this real quick, I'll go over to the report view. I'm actually going to duplicate this page because I like the text size that's on this page. And I'm going to get rid of all of this stuff right here. So I'm going to get rid of all this, just like that. And now I have my total sales and I have this. If I bring in that new measure that we just created called prior week sales, I would expect it to be blank because we're at the month level, and it is. But what happens if I go down in my date table to the week level? So I go down to my week number of year and I add that. Actually, it's already in here. It was already in here. So I can just drill down another level. If I go down, you see it's actually working. This is amazing. I get these questions all the time. Now, let me just focus on this for one moment. When people come to me and they're like, Mitchell, we got a custom calendar, we got a 445, we got to do week over week analysis. How would you do that? A lot of times I'm like, it really depends very heavily on how your date table is built and how your model has been defined. So this Copilot is not going to go in and fix your data model, right? It's not going to go in and add columns that don't exist. It's not going to go in and tell you what's wrong. It's going to leverage what's in your data model. So Copilot, just like anything else, is only going to be as good as the data model you've built. And I've said for a long time, if you've watched, go back and watch the sessions that I've done around data modeling for Power BI. In those sessions, long before we started getting to the AI conversation, I said the most important thing in Power BI is the data modeling aspect. And this becomes even more relevant today than ever before because Copilot is it's leveraging that week number of year to figure out what I want it to do. Now, technically, again, the way it wrote the calculation, this would actually work at the day level because the day only has one week number of year associated with it. So therefore, it should work at that level as well based on the DAX that I saw that it wrote. So this right here is amazing. I want to show you some more complex calculations though, and we want to see what this does. Maybe, hopefully, we actually get something that's wrong because I want to talk about that, but a lot of times it's right and it's really good. So if I create another query, I'm just going to open up a new window. I'm going to do Control I to start that Copilot conversation. And I'm going to do something like, let's see. Oh, I got one. Let's do create a measure that returns period over period sales. So not week over week, period over period. Now I expect this to be wrong based on my analysis, and then we're going to adjust it. So this is going to create a measure that should be looking at the prior period and getting the difference. So this period minus the prior period, so we can just see what is the difference, what is the growth. And as expected, it's actually not fully correct. So if I read this measure starting on line 5, the measure is going to be called period over period sales, and it's getting the prior sales. So the first thing you have to do if you want to subtract the prior sales from the current is you have to go get the prior. And it has decided unilaterally on its own to go get the prior month sales. Well, that doesn't really give me every period. This isn't week over week, month over month, quarter over quarter, year over year. It's just month over month. It's just going back 1 month. So that's not what I want. I want this to be at every level of the date hierarchy. So now I don't like that because it's not at every level. So imagine a scenario where you're like, Mitchell, I had to go in and create a day over day, a week over week, a month over month, quarter over quarter, a year over year measure. That's 5 measures I had to create. Can I just create one measure that does that based on the filtering in the model? The answer actually is yes, you can. And so now we're going to see if Copilot can do that for us. So create a measure that returns period over period sales. That didn't work, but let's add to this prompt. The measure should work at every level of the date hierarchy, including day, week, month, quarter, and year. Pretty good. All right, we're going to hit enter. We're going to give that a moment and we're going to see what it does. All right, so let's take a look at the results. If I scroll, we're already getting a little bit of a prompt here, but let's scroll back up just a little bit. So where I've run into some problems with the Copilot, I don't know why I said the Copilot again, but where I run into some problems with Copilot in the DAX query view is that when I create an initial prompt and I try to add to it, it somehow tries to combine the two and it doesn't work the way I would expect it to. So I personally have found it better to just start a new query and start over, but I wanted to see what this would do. And so it's trying to figure out, okay, prior sales. So it gets the total sales, we need the current sales, and it's counting the number of rows in the date table to compare. And then it's doing this calculation here. So if it's equal to 1 day, then we're at the day level. So go back 1 day. If it's greater than 2, or equal to 2. Actually, I don't think that would work. That should capture, that would capture everything that's greater than, oh, it's got a less than. Okay. So and less than or equal to 7. Perfect. Then go back 1 week. Well, there's not a week parameter you can pass in, so this is actually wrong. You could say -7 days. So we could actually adjust this and do -7 days to go back 1 week. And if we did, this would actually work. Or we could do calculate total sales, and then we could do current week number of year -1. So we could just go back 1 week number of year. So this is actually wrong because it's passing in a parameter that's not a real parameter for DateAdd. So it's wrong. But for the most part, it did build out a really great structure that will work. I would just have to come in here and modify this to kind of finalize it. But it did a lot of the work for me. This is a completely different DAX calculation than I've seen it do in the past. But yeah, then it takes the current sales, which was defined at the very top. Current sales was defined on probably around row 7, the row 8. Row 8 had current sales, and it subtracts the prior sales from that. So let's try this again. I'm actually going to get rid of this one. I'm going to try it from scratch to show you that when you create a prompt and then you try to add to the prompt, it does something kind of weird. But if I do it from scratch, I think it's going to do something a little different. So I'm going to do Control-I here, and I'm going to say create a measure that returns period over, actually let's just do prior period because it's the same calculation, just it doesn't subtract current. That returns prior period sales. The measure should work at every level in the hierarchy, day, week, month, quarter, and year. All right. And we're going to run it again. And so I expect, and I don't know how much this holds on to the cache when it's running it with what it's previously done in Copilot, but I would expect to see a vastly different calculation here than what we got just a moment ago. And so we'll look at what it does. And so again, this is actually a different calculation than I've seen in the past. So let's read through this very briefly here. It's going to create a measure on line 6 that does prior period sales. It's getting the minimum date within the filter context and the maximum date within the filter context. So if you were looking at month, it'd get the first day and the last day of the month, year, first day and last day of the year. Then it's trying to figure out the number of days. So get the number of days within the filter context. And then it adds 1 to it at the end because normally you would lose a day, right? So if it was 31 days in a month, it would return 30. So it adds 1 back in to get the full 31. And then it is saying calculate the total sales for all of the dates that are in this period. Look at the date table, take the minimum date -1. That's going to be the starting parameter. The ending parameter is going to be the negative period days. So period days -30. Oh, go back that number of days. So you get the minimum date -1. So go back to the prior month, go back to the prior year, go back to the prior week, whatever it is. And then go back the number of days. Yeah, I guess that would work. I don't like the way this one was written though. And so it's a little different every time I run this. The one that I've seen it right in the past is where it actually checks is in scope to see what scope you're in within your filter context. So day, week, month, quarter, year. And based on the scope, it then performs a specific calculation. Calculate total sales, DateAdd -1 day, or whatever it is. And so it goes back to the prior period based on that. This is different. So Copilot is it's generating a different result every time. Just like any other programming language, you can write things a multitude of ways. but this looks like it probably would work. It's just not the way that I would have written it. And so let's test this out. I'm going to say keep query, and I am going to update the model with this prior period sales, and we're going to test it very quickly here. So we'll run that. We'll go over to our report view, and I am going to bring in the measure that we just created called prior period sales, and I'm going to drop it right here. And you can see right out the gate at the week level, it works. It's at the week level. It's going back 1 week. It seems to work. Now this one right here, prior week sales. Let me make sure I remember what prior week sales was 100%. If it's that, go back blank. So this is a prior week sales. So this one right here for 31 is off. Oh, it's been split across two. That's a weird one because of the month. I might have to pull the month out just for a moment to see what that looks like. Okay, they all align. All right, I'm going to add the month back in, and then we're going to go up one level to look at it at the month level. And the question is, when I go up to the month level, does it work? And so if I'm looking at December, and this is supposed to be going back to the prior month, and it goes back to November, it doesn't work, right? It's not working. So this actually is not working. It looked great, and this is a concern. Like, I'm glad this happened. We are not going to re-record this. I'm not deleting this. We are going to leave this right here because this is what I see. Customers are calling us up and they're doing virtual mentoring sessions, and I can tell as soon as I see the code, I'm like, oh, you wrote this with Copilot. And what I generally do when somebody calls me up and they want some one-on-one help is I say, let's scratch that. Let's start from scratch, because I need to look at your data model. And what I think is going on with this calculation is it's getting the number of days for the current month, which is different. So if this month is 31, but the prior month is 28, it goes back, but it winds up getting 30 days somehow, right? So now it's getting maybe October 31st through November 30th instead of November 1st through November 30th. So we're getting an extra day, which is why we see a little bit more sales here. So when I say what was the prior month, it's getting 550,000 instead of 543. And my guess is if I were to look at this calculation a little bit closer, it was doing this thing. And I told you I didn't really like this as much as some of the other ways I've seen Copilot write this. It's figuring out the number of period days based on the current filter context. So every month has a different number of days. They vary, right? So like February has 28, unless it's a leap year. March has 31. So if you were going from March to February, the difference would be even bigger probably. So if I go down and look at right here, look at this. February, March, what was the prior month sales? It wasn't 610, it was 550. Why are we getting 610? Because it's adding in 3 additional days from the prior. And it's hard for, maybe I'm not explaining that well. I'm not trying to go into the depth on explaining bad DAX, but this is bad DAX. And a lot of people, here's the danger. A lot of people are going to write this code and not be able to read it because they don't know DAX that well. And they're going to implement bad DAX. And that's going to give bad results. And if you're not really diligent about testing it, because remember, I might have done, if this was something like period over period growth percentage, so we're taking the current minus the previous divided by the previous just to get the percent, this would be a lot harder to the eye test to figure out. So we got to be really careful with that. I want to do one more calculation. I want to show you one more thing here, but that is a cautionary tale. Be careful, make sure you validate anything that you do with DAX. So we're going to do one more, and this is going to be a cool one. Now, I don't know when you would ever actually do this in practicality, but it gives you an idea of other things you could do. Return sales for the top 10% of products. Return the sales for the top 3 products, anything like that. So I'm going to say something like this, Control I, create a measure that returns sales for the top 5 products and the bottom 5 products. So we want to get the bottom 5 and the top 5, and we want to sum the sales amount for only those. So it's a scalar value, it's a single value at the end, but for only those products. Create a measure that returns sales for the top 5 products and the bottom 5 products. I'm going to add nothing else in there. We're going to hit enter, and we're going to let Copilot do its thing, and hopefully this time we'll get a good result. What I would expect to see is 2 separate queries, one that returns a top N that returns the top 5 products, one that returns a top N that returns the bottom 5 products, combine the products together, return the product keys, and then pass the product keys into my final sales. That's what I would expect to see. something to that effect. So let's look and see if it does that. So every time it's a little bit different. So it's getting me a list of all of the product keys right here. So it's getting a list of all the product keys and the sales amount for all the product keys. And then it's saying, okay, from that variable, product sales, I want to return the top 5 based on sales descending. So that's the top 5 products. And then if I go down a little bit further, it returns the bottom 5 products. Perfect. And then right here, it unions them together to give me 10 products, which is my bottom 5 and my top 5. So far, so good. But all we have is a list of the products, right? That's all we have. And so if I go down a little bit further, it says, okay, now that we have a list of all the products we want to get sales for, let's calculate total sales right here. And then we're going to pass in. And I'm surprised it did this here instead of separately in a variable to make it more readable. But what it's doing here is it's saying, okay, from that selected products table variable, there's actually 2 columns in there still. And so there's 2 columns. There was product key and there was total sales, if you remember what it did at the very beginning. And so this is saying, hey, only bring back the product keys from that table. Just bring back product keys. And then we're taking product keys and it's using treat as to create a virtual relationship. And it's saying, filter down the product table, filter down the product keys in the product table based on this list of products that we just created and determined, which is my top 5 and my bottom 5. So it's passing that in, and then it's getting the total sales for just those 10 products. So this is really cool. And so again, if you don't know DAX that well and you haven't spent time investing and learning it, how would you be able to validate or verify that this is correct? Now, what's cool about this is I'm going to actually say keep query, because this is correct. I'm going to say keep query, even though it was written differently than I've seen in the past. And I'm going to hit Control+I to run Copilot. And I'm going to tell it something like this. This is amazing. Explain to me, or explain what treat as is doing in this measure. And this is going to be really amazing. And so the cool thing about this is that you can take existing measures that other people have built or you've built in the past, and you can bring it in here and you can ask Copilot to actually explain to you what it's doing. And so it's going to come in here and it says, in the provided DAX code, treat as function is used to apply a filter to the fact sales table based on the selected products, top 5 and top 5 to bottom 5. And so it goes through that. And if you click show more, it winds up breaking down the calculation and actually explaining it step by step by step. And it's really, really good. I love the definitions and the explanations in here. And so, as I mentioned earlier, be very careful with Copilot, but that should not discourage you from using Copilot. It is unbelievable and it is amazing what Copilot can do, but it is going to be somewhat, reliant on you understanding and taking the time to debug it and test it and make sure that it's right. Because one of the things that is different about DAX, and you can use Copilot to write Python, to write KQL, to write SQL, to write many different languages, right? Copilot is going to be very much known as an accelerator for development. And so if you're working today, you have to start to adopt these technologies just to be more efficient at your job, right? And so that's going to be very important. But what's important also about working with Copilot and leveraging it here is making sure that we take the time to actually validate and verify that those results are correct. Because in DAX, when we build measures in DAX, we build measures knowing that there is a current filter context. And we build a measure usually for a specific visual. But we always have to be careful to think through how might other people use this measure, or what filters might they add. Because when you change the filter context, the values change automatically, dynamically. And if the measure that was created by Copilot or yourself isn't thinking about future filters that could be applied, then the results could be wrong. And I'll take you back for just a moment to the unexpected failed experiment with the prior period cells. If I just stopped at week and week looked amazing and week looked great, and I didn't go back and validate at the month level, I would have never known that it was wrong. But as soon as I changed the filter context, it was. So be careful with it, but use it and test it out and explore it, because it's going to make your job and your experience a lot easier. I just want to take a moment here and say thank you for joining us today in this special session that we had around DAX. I appreciate Greg joining me as well. And if you are watching this live, we are doing a Q&A, a live question and answer session immediately after this session. So we'll see you there. Thank you, and we'll see you next time.